it afterwards. And
Yeah, thanks a lot.
yeah, yeah. Thank you. So, Sebastian, sorry for the interruption.
Don't worry.
Yeah,
No,
thank you.
okay, yes, yes, of course. Recording is always good. We at Zoom are all in favor of that. Besides the recording, Laurent was also kind to accept my request to activate the AI companion in this meeting. So if you want to try out some of the technology I'm presenting today live for this meeting, you can just hit the AI companion and start typing away and can have questions answered on this meeting or get the intermediate summaries of these meetings. And after the meeting, the whole recording ends, we should also be getting a summarization of the whole workshop and the whole recording that Laurent then can also distribute to all participants. Yes, so as said, Andre and Laurent were so kind to already introduce me a little bit and give a little bit of background on the connection that we have. It's true. So I spent most of my career at KIT in academia, starting out in automatic speech recognition, then expanding into speech translation, and then also getting into the field somewhat of speech summarization, as at least in a pipelined approach, speech transcription is a fundamental block of doing summarization of spoken content. And when it comes to multilingual spoken content that you want to summarize, then translation can, depending on your setup, also play a crucial part in that. So I started out as a PhD student researcher, then went into a postdoc, became a research group leader, a deputy professor, and then in 2015, Alex Weibel, my former PhD advisor, and we also founded a little startup company, which we called Kites, in which we were mainly doing speech-to-speech translation. We were doing it for in-person events, for live events, and then the COVID pandemic hit. And we had to switch from in-person events to virtual events. And so we came in contact with all different kinds of video conferencing solutions and video streaming solutions, because people were transitioning from in-person events rapidly to virtual events. And among these platforms was also Zoom. And we wanted to integrate our speech translation, live speech translation better into the Zoom platform. We had a first way in via an API that was actually meant for manual transcriptions. So we thought we could do it better if we integrate better. So we tried to get Zoom as a customer. And after a year or so of discussion, Zoom actually then decided to acquire that company, Kites. And that's when I also had to give up my position at KIT. Together with a couple of colleagues that split their time between KIT and our startup company. And that's when we, to the dismay of Andre, also had to leave the Elita project, unfortunately, which, however, still went on fine, I think, because the remaining colleagues at KIT were also good researchers and developers in the field of automatic speech recognition. So you are still in good hands. So what did we do since then at Zoom? Same as ever. We did speech translation and brought speech translation and speech transcription capabilities into the Zoom product family. When we arrived at Zoom, Zoom was offering transcriptions in English only, and they were using a third-party vendor for that. And our task was to internally build up a speech transcription and speech translation capability for 30 plus languages. So that was our task for the first 2 years. But what we also did is we started out to look into the field of speech summarization and produced a very first speech summarization system for English that was deployed within the Zoom product family. And that was during these first 2 years. And at that point in time, it already became clear that transcription translation is a commodity, and the real value is in digging deeper into the spoken and visual content of these online meetings that were now happening all the time. So that it was clear that Zoom wanted to heavily invest in AI capability to use all kinds of AI technology on top of the meeting content to offer services to the customers. And that, of course, includes things like speech summarization, minutes, but also more complex tasks like asking questions on the content of a meeting, providing different kinds of summarization. So your regular summarization, verbose ones, short ones, next steps, observing communication, acting as a coach, and many more things which I'm going to present, which are all either at least related to speech summarization, or depending on how you phrase the actual task of speech summarization, could be a variant, a corner case of speech summarization, or a very specialized case of speech summarization. So that's what I've been up to. So when we went to Zoom, we were a team of 11 people. We expanded a little bit in Germany. We're now 14 people on the team in Germany that is now exclusively focusing on speech translation, but we are closely collaborating now with many more colleagues in the US and all over the world that are working on summarization and nowadays, of course, working with large language models to provide all different kinds of AI services, for which we, among others, produce the transcription and help out with translation. So what I was thinking about and wanted to talk about today is about 4 topics, essentially. First, I wanted to give you a little bit of a better overview of what Zoom as a company actually does. And what Zoom does is unified communication. Some might be familiar with that term, maybe more familiar than I am. For some, it might not be such a familiar term. So I wanted to give a little bit of an insight into what we mean when we talk about unified communication. You might have heard Zoom has recently, well, it's over a year ago now, changed its name. In the beginning, it was Zoom Video Communication, because Zoom Meeting is the product you know and the tool we all use. But in reality, Zoom is a wide range of different communication tools that are not necessarily all video-based, so that Zoom has actually changed its name into Zoom Communications in order to reflect that change. And then I would like to just touch upon a couple of selected research questions that came to my mind and that I frequently think about when it comes to summarization, things that are work in progress, that people have worked on, people are working on, and that I find interesting. And I don't want to give an in-depth survey of all the different research questions. Instead, I would try to touch upon different topics, give my perspective, raise a couple of questions, and sort of try to give some different angles on these research questions. And then, of course, since I'm from Zoom, I would like to present you some of the applications in which we're using speech summarization and how they're being used in our many different applications. And they, of course, also connect somewhat to the selected research questions that we have. The thing is, we at Zoom, we are a small company, let's say, compared to something like Naver or Google or Microsoft. We don't have a dedicated research department. Whatever we do in research has always to be directly connected to a product and to the question, how does it improve the user experience? How does it make the product better for the users? And whatever we do in terms of research needs to be always fast-tracked into a product. So these applications and the research questions that we think about are very well connected, because whatever we notice in the application or the functionality that we want to provide, that is always the foundation of the research we're doing and we're thinking about. And then, of course, again, time flies not that fast. As of this spring, I think, January, February, the latest buzzword term in AI is now AI agents. And AI agents are somewhat, or can easily be linked to the task of summarization and speech summarization. And at Zoom, our CTO, Judong Wang, XD for short, and that's what he's often known as in the community, has coined this term from conversation to completion. And to get to that, we are working on the concept of using AI agents of getting from this conversation to completion. And I will get a little bit into that, what it means. And I then will link it again to a European project that is being currently conducted, that is working in the field of AI agents, and summarization is part of it. The project is called Mitrin. So I will touch shortly upon it at the end of my talk. And I'm pretty sure Sebastian, who is actually the coordinator of Mitrin, will then in his keynote also give you more information and background on that project. I've been planning to talk for maybe something like 30 minutes or so that we can also have a chance to do have some discussions. However, since we are in a somewhat smaller circle, if you have any questions or discussions or any comments, just interrupt me anytime, and happy to pick up the conversation. So what is unified communication? What do we mean by it? What are these many facets of unified communication? So when people hear Zoom and think about Zoom, the average person always thinks of Zoom meeting, but Zoom meeting is only one application among many that Zoom nowadays offers. And Zoom is indeed a unified communication platform. And what are these different types of communication that are now being unified? So one dimension that you can use to break that down would be the modalities used in the communication. Can be speech, can be text, can be images, can be video. So you can have a phone call that would be speech only. You could have a video meeting that's speech and video. You could be writing a document. You could be writing a chat message. You could be writing a traditional SMS message. That would be then a text. Or you could be creating a video. You could be creating an image. You could be working with a whiteboard, creating a drawing, a diagram on a whiteboard that again would be an image. So these are all different kinds of modalities, and it's definitely not a comprehensive list that we use to communicate. Or you could break down the different types of communications via the tools we're using. So it could be a video conferencing, as we're doing today. So we either have a desktop application or you have an application on your mobile phone where you are conducting a video call, a video meeting. Or it could be a traditional telephone call. And you would be surprised what a big role telephony still plays in the business world. When it comes to customer communication, when it comes to communication within companies. Phones are still very much used and are a different application and feel and work differently from a video conferencing platform. It could be a webinar. So if you have few people talking to a larger crowd of people so you have a clear division between presenters and an audience, a webinar could be a better tool for doing it. And there's also a Zoom webinar product where you can have these Zooms. Or when it comes to customer relations, contact centers are a very important tool that companies keep in contact with their customers, where they offer services. And there you'd have, again, another type of communication. For the customer, it might look like they're just picking up the phone and calling somebody. But if you're on the agent side at the company, your view of the tool will look completely different than traditional chat. So Slack, or to Zoom has something called Team Chat, that is our chat application, are also a very nice way for asynchronous written communication. So for these different tools, we have different applications. And one thing that is very common to all these different applications is, it's not the only thing, but it's one important thing. In all these different communication situations, summarization is an important feature that really benefits these communication scenarios, and we are working on, and we've already successfully done so, integrate summarization capabilities into all these different products. And not only summarization, but then even more advanced features, some of them which build either on transcription, translation, or upon summarization themselves. So the way we think about it at Zoom is we have these many different applications, and every one of these small white icons is the name of an application that Zoom offers as a product. Some things we call the workplace, that is what people are working and use communication tools to support their regular work. Some things are more called business services. That is when you typically have a business communicating with a customer. And the thing that the big bracket that holds everything together is what we call AI Companion. And AI Companion is the name of all the different AI functionalities and features that we are offering in our products, and that also is able to work across the different products, so that you can summarize across all these different products and get a summary and can transfer a summary from one product to the other and use it either in your work or you use it in the business services that you're actually offering. And then, in addition to the products that we are offering, we also have an ecosystem of things like SDKs and an app marketplace where you can come and use the basic features in Zoom to build your own application. Can be a completely own application. So you can build your application, and via SDKs, you can then use basic functionalities like video transmission, audio transmission, and AI functionality integrated into your application. Or you can just build an app that you plug into the actual Zoom product and offer that app via the marketplace. Or you can even start to create your own AI system using AI Studios. So using AI Studio to create AI functionality by writing, for example, prompts and specifying which underlying large language model you actually want to send that prompt to and in order to offer that functionality. And we then also have AI Companion reach out into other products, so that AI Companion becomes available within the Microsoft product or within the Google products of Salesforce, Atlassian, and ServiceNow. So those are the other big product suites that we now support and offer the integration of AI Companion into. So when it comes to summarization, here's some of the research questions that I, in my individual, subjective, personal opinion, find relevant and interesting, and I think are being actively worked on and should be worked on, and are actually open questions. And the first question that always comes to my mind, and which is a frequent discussion that we're having amongst each other, but that is probably also out there in the research community, is when we do speech summarization, what is better, to do a pipelined approach or to do an end-to-end approach? And if you've worked in the field of speech translation, you know exactly that question because it has been around for decades at that point, I think. And in the end, it's exactly the same question here for speech summarization. So what is better? Do we do a pipeline where we first do a transcription and then we summarize the transcript? Or do we do an end-to-end model where we have a model that directly consumes the speech and produces the summary as an output? And what are some of the advantages and disadvantages? What are the different aspects that you need to consider if you want to choose one or the other? If you look at the pipeline, one of the obvious advantages is that you can optimize the individual tasks. So you can optimize the transcription and you can optimize the summarization of text. And what does it mean to optimize? Nowadays, in the age of machine learning, it very often all boils down to the amount of available training data. When it comes to speech transcription, the amount of training data out there has grown a lot over the last, let's say, 40 or so years. You know, when we started out in speech transcription, we were often very happy if we got 10 hours of data, and then over time it became 100 hours of training data, where the standard then 1,000 hours was really great, but then it quickly became the standard. Nowadays, if you look into a commercial setting, it's not unusual to have tens of thousands, hundreds of thousands, 1 million hours of training data for speech transcription. And given the current infrastructure and the current availability of data, it is actually feasible to get 1 million hours of transcribed speech data to train a transcription system. If you do summarization, and we're not talking only about text summarization, you know very well that the amount of training data is a critical issue, and it's not easy to get training data. So already for text summarization, getting text and their summaries to learn from is difficult. There are corpora now out there which offer a significant, reasonable amount of data, but the amount of specific, especially manually annotated data, is probably still an orders of magnitude lower than for older tasks like transcription. Now, if you flip the coin and look at end-to-end speech translation, it means you would need speech recordings and you would need the summaries of these speech recordings. And as you very well know, that training data is even less available. And that, of course, makes it difficult then to train an end-to-end system. And if we look at what happened for summarization, what really surprised probably everybody is that instead of having a dedicated text summarization systems, these large language models that are sort of pre-trained on an auxiliary task in the end, skipgrams or whatever you do for doing the pre-training, and then fine-tuned, nowadays work a lot better than the old dedicated summarization systems that we used to have. And the question is, when it comes to data, is that also an approach that might work for end-to-end systems? Difficult to say. There's active research. We'll have to see where the wind is blowing, what will happen eventually. And evaluation tasks like AUTOMIN are an important tool in answering that question and eliciting research from the community to answer these kinds of questions. And another interesting aspect of the pipeline is that it becomes easier to deal with multilinguality. Very often, as it is the case, the task of summarization is addressed for English. So you work on summarizing English text or summarizing English speech for meetings. But then, as you all know, the number of languages in the world is really vast. So estimates range from 4,000 to 7,000. If we look at what is being used in business contexts and in daily lives, hundreds of languages are regularly used. And of course, speech summarization technology should also be available for them. So a simple trick you can now do in the pipeline task is that you also make use of the fact that it is comparatively easy to get training data for machine translation systems. So you can very often train machine translation systems for languages, and let's say from and to English, that you would have difficulties for finding enough training data to do a summarization, a text summarization system. So the simple and easy trick is you do transcription in the original language, you translate into a pivot language. English often is the language of choice. You summarize in English and then you translate back into your source language. And in that way, you can offer a speech summarization system in many different languages and a text summarization system in many different languages. And you only need to worry about having a summarization system for English, which makes it easy. The disadvantage, of course, is always that you have the danger of error propagation. So if transcription makes an error, it's difficult for the summarization to recover from that if you do it in the multilingual setting. So if machine translation does an error on top of ASR, these errors have a tendency to propagate. And in principle, if we look at it from a more abstract point of view, of course, we have a situation where we have this continuous signal speech. We transform it into a sequence of discrete symbols, text, which we then summarize to get the final discrete result, the summary. And in this process of transforming a continuous signal into a discrete representation before we do the summarization, we're probably already losing a lot of information. We're getting rid of a lot of redundant information. That's for sure. That's probably an advantage. But we also have the danger of using additional information that might help us in guiding our summarization. And then that is one of the obvious advantages of an end-to-end system, that you can make use of the full information and the speech signal. So that could be, for example, paralinguistics, things like emphasis, and other paralinguistic clues, emotions, etc., are missing from the textual representation upon which you do the summarization, but it's there in the speech signal and might guide you. Things that get emphasized might be more important to a summary. When emotions flare up, maybe that's a portion of the conversation that you should pay specific attention to when it comes to summarizing it, when it comes to providing a conclusion. So if a conflict is settled and there's a final conclusion that settles the conflict, it's probably good for the summarization to include that final conclusion in a prominent way. You are able to ingest other channels. So for example, video channel, you can ingest the slides that you see in a meeting to also include that into the summary. So that makes it easier. And then from an abstract point of view, the simplified architecture is more beautiful. So it's more beautiful from architectural point of view to have one monolithic model that does everything instead of having to optimize these different steps in the pipeline. Another interesting aspect that I often encounter when working at Zoom with the different products is the question of how to do offline and how to do incremental summarization, and how are they different? What do we do to do differently for these different types of situations? So in offline summarization, you always have the full context available. You have the full document, you have the transcript of the full meeting, and you can summarize that. And the only problem that you might have, depending on what kind of summarization system you have, it could be that the summarization system has a limit on the length of input data it could ingest in order to produce a summary. If that is the case, then you need to do some sort of pre-segmentation, and then you summarize the individual pre-segmented blocks, and then you need to merge the summarization somehow. But if that's not a problem, then in offline, you have full context, and even things mentioned at the end of a meeting can be used for the summary that would appear at the beginning of the summary and might be connected to something that happened at the beginning of a meeting or at the beginning of a text. In incremental or online summarization, the full information is not available. And why is online or incremental summarization actually useful? Well, let's go back to the example I already mentioned, the customer agent sitting in a contact center, working with a customer call and doing customer service. For them, it's very often helpful if they get an intermediate summary of the conversation, especially if it is a longer task, so that they can see whether they covered everything, what they talked about in the beginning, etc., in order to get the to get to a better final resolution, to have a better tool on working on the customer interaction. Or if you're in a meeting like this, you can, and let's say you either forgot, you were distracted, you were late, you can then just ask the video conferencing system to catch you up on what happened so far, and you get the intermediate summary. And if it's a longer meeting, and I know you're coordinating a meeting with many people and you need to do many different things at the same time, moderate, participate, make sure that all the topics are being covered, you can always have an intermediate summary that tells you what happened so far, and from that you can infer, okay, what is missing, what do I need to work on when I'm moderating a meeting. So then from the problem that in online summarization, you have to work on incomplete information. You also come directly to the question, okay, what do you do if you update a summary? Ideally, when you update the summary, you only add new information and you leave the old information untouched. But of course, as new information comes in, you might be able to be more precise in the old summary that you've already provided. So you might want to rewrite it. So finding the balance, striking the right balance on fluctuating on the summary you've output so far and updating it for quality and precision reasons so that it is still good for human consumption is the true art here. And what the right balance is very often then also depends on the concrete application you're working on. Then you have to balance the quality versus the latency. So if you wait longer before producing intermediate summaries, you might be able to produce higher quality, but you will see updates less frequency. While if you have update more often, your quality in the summarization might actually suffer. So as an example for first work on that question, for meeting summarization, I've quoted here the work done by my colleagues Felix Schneider, Marco Turki, and Alex Bible, which is available on Archive, where they took a look at how to do online summarization. They looked at strategies and they looked at the question of actually how to evaluate these things. And what they did in their approach and the framework that they proposed, they took the paradigm of read, write, and erase for doing incremental summarization, and this paradigm comes actually from online translation. The questions you encounter there are actually quite similar. So you read input, you write your summarization, and you can erase old summarization, and by writing you can replace then old summarizations. And the question now is, when and how do you produce an intermediate summary? At what point in time do you do that? And for that, they had proposed and looked at different segmentation strategies that they looked at. So they looked at strategies that were length-based. Length meaning the length of the input coming in so far, and based on the length of the input coming in, you decide when to produce your next summary. Or they used model-based segmentation. And for that, they basically summarize all the time as data comes in up to a certain maximum threshold. And then they have a model-based quality estimator that estimates from these many different intermediate summaries that I've produced up to the maximum latency threshold, which one is the best one. That they put out, everything that went into that summary gets forgotten, and everything that came after that summary then goes into the next cycle of producing incremental summaries all the time, having a model judge all these many different intermediate summaries, and then deciding again, okay, which is the one I want to put out. Or you do a sliding window, where you always have a sliding window of a fixed size, and you summarize that sliding window from time to time. Or you summarize constantly, and then you always fully rewrite what you've done, or you do something which is called fully incremental. And if you want to do fully incremental, you have to be careful with the summarization module that you have, that if you do fully incremental, you ideally keep the summary that you've put out so far fixed as a fixed prefix. The fixed prefix also becomes an input into the summary in addition to the additional data you've received, and then you output again a summary. And these different strategies have different requirements for the type of summarization model you need. In principle, as they state in their paper, any type of summarization model should more or less work with all the different segmentation strategies, but in reality, there are a couple of side constraints that need to be fulfilled. So for example, for the model-based segmentation, you need, of course, a quality estimator. Without the quality estimator, you won't be able to decide which intermediate summary you want to put out. excuse me, I'm recovering from a cold, so I'm afraid you have to put up with me from time to time taking a sip of water. For some of the other strategies, you need to be, for example, able to work with very long input. You need to be able to do a very long input, process a very long input with your model. Otherwise, it won't work. And then for some of the strategies, it might be beneficial, if you want to reduce flickering, to actually be able to fix your prefix. So if you are interested in that topic, I highly recommend that you take a look at that paper. There they give you much more detail and evaluations on these different combinations of these different strategies with different metrics, not only on the summarization quality, but also on the flickering, on the latency as additional metrics. And they do everything on, I think, the data from the first AUTOMIN workshop, actually. So they present results for that. And then the third topic I wanted to just touch upon is, of course, the question of evaluation. How do we evaluate summarization systems? Of course, I'm preaching here to the choir, as you're all part of an evaluation campaign that is evaluation summarization. But for me, it is still not 100% clear. And I think for the community, there's also not 100% alignment on what do we actually want to measure? What kind of properties make a summary a good summary? So some people talk about they want to measure the adequacy, the fluency, and the relevance of a summary. In other papers, I've seen that they want to measure the conciseness, completeness, and truthfulness. And some of them might be just different ways of wording it, but some of them actually might be different or might be missing something. So the first set has fluency in there. So it should not only be complete and truthful and adequate and relevant, but it should also be nice to read. The second set of metrics actually does not really have this, it's nice to read, as fluent kind of thing in there. Might have to do with the fact that nowadays many people use large language models, and that might actually be then the reason that they don't look at fluency that much anymore, because whatever these language models put out is fluent. Whether it's correct and truthful is a different question. And then you also want to maybe look at additional attributes. So verbosity, how long is your summary? Is the length of the summary actually adequate for the application in which you want to have the summary? And with the advent of large language models, but also before that, hallucinations are, of course, an important phenomenon to look out for, and you might want to measure for that. And I guess that's one of the reasons why one of the system papers in the presentation specifically also mentions hallucinations as one of the interesting aspects to look into. So as you all know, you all know that. So from my point of view, as I see it, we essentially have three different types of evaluations that we can run. So traditionally, you have the reference-based one. So you have a test data and you have a human-created reference summarization. And then you need some sort of measure that tells you how close is the automatic summarization to this human summarization. So the Rouge score, the BERT score are all related to that. So at a high level, you can look at precision and recall in the end if you want to look at it that way. And you essentially have the same kind of problem that you have when it comes to evaluating machine translation system in the end. And then, of course, you have the human evaluation. The question of human evaluation essentially tells you, is sort of the gold standard, but it's difficult to be consistent. You need many evaluators. It takes a lot of time. It's very expensive. You cannot run it that often. You can definitely not do continuous system development. And then the latest trends with the large language models that we now have is that we now use large language models as judges. So we ask a large language model, is that automatic summary a good summary or not a good summary? Some people just use a single language model to do that. other people use a panel of different language models and then combine these different language model scores together. And of course, that approach also has its problems because large language models are not humans. They don't judge like humans. And when people do these kinds of evaluations, they've seen interesting phenomena. For example, when you work with a panel of with a large, if you do a sort of a ranking side by side, this is what sometimes people do, is sort of tournament style. Summary A, summary B, which one is the better one? There are language models that have a tendency to always say, the second one is always the better ones. So you have to make sure that you randomize in order to take that bias out of it. Or if you have a summarization system that is based on GPT something, you probably should not only ask GPT-4 as the judge to tell you how good your summary is. That thing might be biased to the types of summaries it is putting on. And then when you look at online summarization, of course, in addition, you have to look for latency and rewriting, flickering, etc. And everything is, of course, governed by a lack of good test data. And in the end, what it does not measure is how good is a summary compared to what my organization wants to have as a summary. And that is essentially the last point I wanted to touch upon, and that is customization. Different organizations, different settings, different applications might have completely different standards of what they consider to be the correct and adequate summary. For example, if you look at meeting minutes, certain types of meetings might have specific legal requirements. So, for example, board meetings of a publicly traded company have certain requirements of what the minutes, what the summaries of these meetings have to look like. Or you simply might have company internal guidelines, policies that tell you what the summaries for certain things should look like. A summarization of text and text collections might have to look completely different from a summary, for example, of customer interactions. And different types of businesses might have to have different templates from customer interaction. So retail customer service summaries might have to be completely different from, let's say, financial services summaries. Very often you need to be able to customize also not only the style and type of output, but also to the domain and content. Certain domains have specific words, have specific company glossaries. Companies might have their own terminology and terminology lists and named entities that they want to use. And very often adaptation data, unsupervised adaptation data on these things are available. There are company glossaries available. There are the transcripts of prior meetings available, etc. So data is there. You now need to be able to actually ingest that data to customize your summarization to the domain and to the style of the company. And that can be done very well with large language models. So via the power of instruction following, via prompting, you can try these things. You can try few shot learning in order to adapt yourself to the template. You can even do instructions. You can try to do some fine tuning on a small amount of language data, of adaptation data. You can do customization both for the pipeline and for the end-to-end approach, but the end-to-end approach now has the beauty that it lends itself better to being able to ingest all different kinds of multimodal data in order to do the customization. And then, in addition to that, of course, nowadays, retrieval augmented generation is very important in that context, also for summarization, by being able to find relevant documents that contain relevant meta and context information provided to the summarization component in addition to the actual content that needs to be summarized in order to come up with a better summary. At the same time, you need to be able that you don't ingest stuff into that model that is confidential and that you don't want to be in that summary. You don't want to have a summary sent out to a meeting that includes external participants and that suddenly also can disclose information that is supposed to be confidential because your retrieval augmented generation system actually gave that information to the summarization system. So there's a fine balance that needs to be struck, and security is again there also an important question. I think I've already talked almost too long, Andre, right? We have got another 5 minutes, or what is the plan?
Yeah, I guess you can take a few more minutes. We have a break, so we can shorter the break if needed.
No, that's totally fine. So I'll just quickly rush through the application examples. They're probably not, we can do that very briefly. So for the meeting, for example, we have this doing meetings, those questions, and the standard question that we offer is always catch me up. And that is essentially a summary of what has happened so far in the meeting. So if you were distracted or late, you can be brought up to speed and nobody is going to notice. Or if you have your meeting and you don't necessarily need to record your meeting, you can also, of course, then get a meeting summary of that meeting, and you will get a meeting summary of this meeting after the meeting ends because AM Companion was activated. And there you can get a sort of a summary, and in addition to a collection of next steps that actually should be taken. You can do that on recordings of meetings as well, of course. And then we have team chat, and team chat can, those chats can be very lengthy. So in these team chats, you can also then actually go ahead and summarize this team chat. So if you come back after 2 weeks of vacation and you have no idea what's going on and you want to read all these different messages, you can just get yourself a summary of that thread, and then it tells you what you've missed, and you can dive directly back into work, for example. And you can do the same thing for phone calls,
just summaries. You can focus on the conversation, and
just like you can do for real meetings. After a call, you can also get, of course, the summary of that call, and if it was a customer interaction, that is then, of course, very helpful. And then the other thing is that you're now also able to customize your AI companion. And you can do that by tweaking the prompts that you want the summary to be generated with, by uploading custom word dictionaries and custom terminology, so that you actually can get a more personalized summary that better fits your tools. And here the real challenge is, of course, to present it in such a way to the customer that somebody that is not a researcher in the field of summarization can actually create these templates for doing the correct summary that you want to get.
Call some.
A different flavor of summaries for phones is then in the contact center. There it's called Smart Notes. So after a call, you can get the notes of what you've seen, and then you get some more metadata in addition to the summary, but of course also what is the next steps that need to be taken. And there is now a nice application which I like, because we as researchers often don't think about it. It's called something called Zoom Revenue Accelerator. That's actually a tool for salespeople. So the guys that call you up and try to sell you something, and it acts as a coach of making you a better salesperson. So it analyzes your whole interaction, tells you what is your talk to listen ratio. Are you not allowing the customer to ask questions? Are you talking too fast? What was the sentiment? And then what were all the topics covered? Did you cover all the topics you need to cover? What is the general summary of it? So that you then know what was discussed with the customer. In the next call, you can catch up and you also don't miss anything. Then the latest one, what we have is the voice recorder, which is neat because this is for in-person meetings. So it started out as the in-person meeting summarization. So essentially you can put your phone on the lunch table when you have a lunch meeting. You can record your lunch meeting that you're having in person, or if you're sitting at a meeting table, if you're in a class or a presentation. And at the end, you also then can get the summary of what has been set in this person meeting. So to the final step, what I wanted to quickly touch upon, and Sebastian is going to pick that up, is then we're now beyond the basic commodities like transcription, translation, or summarization, and we now are on AI agents. And our hypothesis is that everything starts with a conversation, or at least most of the things that are being done in companies start with a conversation, start with a meeting that kicks off a project that then later on monitors progress, that defines who's going to do what and what needs to be done, what needs to be ticked off. And summaries of these meetings are very useful and very important. But the summary is only documentation, it's not action, it's not implementation. So a project is only successful if it is also implemented, if action is taken. And now, nowadays, the AI systems are now at the point where they can take action. They don't only summarize and tell you what the next steps are, but they actually might be able to do parts of it. They might be able to write code, to write a draft of a document, actually do a design of a UI and write a marketing material, etc., etc. So we are now already taking the step for not only supporting the work of the human, but actually also doing work themselves. And also they can, as an agent, represent you in a meeting. We all have too many meetings, and often we have meetings in parallel. And if it is a meeting where you just have to present something, it's sort of a routine meeting, you might be able to send a digital representation of yourself that does the routine presentation, status update, while in parallel you take a more important meeting in which you are really required as a person. And this thing we actually had proposed already in 2023 in a proposal for a European project called Between, which is coordinated by Translated, the company that Sebastian is from, and has a couple of partners from industry and from academia. And there are essentially two aspects. There's the research and development aspect, where we're looking into large multimodal foundational language models that we then apply to different tasks, such as transcription, translation, but also text summarization, speech summarization, spoken question answering. And upon these basic tasks and skills, we then want to build two virtual agents. One we call Butler. That is the passive agent that sits in a meeting, listens, and provides support and assistance to the human participants in the meetings. And then the more advanced one, the more visionary one, is called Agenta. That is your stand-in that you then can send to a meeting to represent you within guardrails that you defined beforehand. It can present what you presented, it then can later report back to you what you missed. And in that way, you can multiply your working power. You can become more efficient by being literally in multiple meetings and panels. And yeah, that is what Butler and Agenta do. And on top of that, everything has to be seamlessly multilingual because it's a European project, and the European Union is a poster example of a space that is inherently multilingual, in which many languages are spoken and in which all languages should be equally supported. So that's that, and let's dive into some questions or comments I'm sure you will all have.
Thanks a lot. And yes, we can take a few questions, even though we are a bit late, but still, if anyone has some question, please go ahead, mute your mic.
Maybe I can, quick question. So yeah, thanks a lot for the great talk, Sebastian. So my question was about online meeting summarization, which you quickly talked about. So I was wondering if this technique can cause some kind of position biases compared to the offline method. Because intuitively, it seems that in the online case, the early information is more likely to be erased or replaced with information contained in the later parts of the meeting. So yeah, I was wondering if you had any insights on that.
Yeah. So the first possibility to deal with that is, I think in the paper they call it prefix fixing. I've seen other people call it differently. Basically, what you've produced as a summary so far is not erased, but it stands. So then it is a truly incremental summary where you have zero rewriting, zero flickering. That, of course, can help. Then the other thing is, of course, if you do this policy where you always summarize everything, then you're basically, the last summary you will do is almost like an offline summary. So there the position biasing is there as much as it is in your offline system. Nowadays, if you use large language models for summarization, prompting can be very powerful. Prompting can be a tool. It's not a guarantee, but typically it works as a tool for making sure that you fix your prefix. Nowadays, the latest large language models, of course, are so big that they can always ingest the full context. And if you're willing to put in the computational power, then probably not so much of a problem. The question whether position biasing is actually a good or bad thing probably also heavily depends on the application. Don't hold me now to give you a concrete example, but I'm pretty sure if we look at the different applications for incremental summarization, you might actually find summaries, settings of applications for an incremental summarization where you want to have positional biasing, where what was said recently is more important than what was said at the beginning.
Okay, thank you.
Hi Sebastian. It was a very nice presentation, and yeah, I'm glad you talked about hallucination as well. So one point I wanted to, but before that, I had one question about the summarization of languages, right? So I'm also working on summarization for Indian languages. There is a rich set of languages, but there is hardly much of a content available, right? So we do is we translate it. So luckily Hindi has something, and I was able to do on it. But there are some languages which we still have an issue here, right? And you talked about a translation and then do the work and then retransfer back, right? So when we do these things, there's one catch we have is about the how good is our transcription or how is good is our translation system. So if I can translate back to the same thing, so do you see the application of back translation here can actually benefit something as an evaluator? Because right? If you said me something, I translate in English, and if I am able to translate back to the same language, it by sense it works. But do you see that such applications are actually making their existence in this era?
For that, I can right now only speak from a perspective of a speech-to-speech translation system, because their back translation has been a common technique in trying to do error detection and error correction. So if we take a huge step back, if we look at AI systems in general and human-computer interaction in general, we all know our AI systems do commit errors. They are not 100% perfect. So the big advice when designing an AI application always is to pay attention to error detection and error recovery. So detect when the AI system made an error and provide a mechanism for correcting that error. And back translation has been used in speech-to-speech translation scenarios where it's really critical that you detect errors. For example, human-doctor interactions. That is a very common technique that, you see what has been transcribed, so you can check whether the transcription is correct. And then you see the back translation of what has been translated. And if the back translation has the same sense as what you have said, then you can be sort of confident that, the translation probably is right. It's not a guarantee, but it's a good indicator. How to combine that now with a summarization system is probably more difficult, I would guess. I mean, what you can do, the person in the meeting knows what the sort of there's a sort of the error correction detection mechanism by humans. So a human has to look at the summary and has to detect whether it fits what the user recalls from what the summary should be, and then do manual corrections, and maybe everybody does it. And then question is, are you saving enough time to make it worth it? But informally speaking, in our experience, when it comes to doing summarizations for multiple languages, the translate to English, or in your case to Hindi, summarize, translate back, works pretty well for a large variety of languages, and there are only multilingual large language models available right now that can do summarization for a very small number of languages. So for very many languages, this seems to be a very good approach.
Okay, that's nice.
Okay. Yeah, maybe we have time for a very last quick questions, if any.
If there's nobody, then I will have a question, but I'm not sure if the answer could be short. Your opinion on LLM as a judge. So do you trust it or not? Because I'll mention that in the overview presentation. So how often and how much you rely on LLMs for judging your intermediate results and driving your research?
If you're doing it right, it can be a very accurate tool, but you have to be careful that there are some traps that you should not fall into.
Okay, so then we'll have to take offline what are the traps and the tricks, because yeah, you'll hear my opinion in a moment.
Yeah, if Sebastian, you are staying a little bit more for the workshop, maybe there can be some questions for the chat as well. But I propose that now we move towards the next presentation, which is an overview of the results of AUTOMIN 2025. So yeah, Andre, I just
Yes.
extract.
That I start presenting, and for the task B, I'll simply give the word to you, but I'll keep
Yeah, go
sharing
ahead.
screen.
Let's do this. Let's do this.
So I'll just share, hopefully, the right window. So please confirm that you can see the findings of the third AUTOMIN challenge.
Yes.
Does that work? Yes. Okay. So I'll summarize, and I'll try to be quicker than planned so that we have some of the break possibly, but we'll see. What we did this time. So it's the third instance of the meeting summarization task. It runs biannually so far, and maybe we will keep that, and maybe we'll have another autumn in 2027. We'll see. There are always multiple tasks. The first one is task A, which has been stable over the years, and it's to summarize transcripts into structured minutes. And then task B, which was introduced by Naver Labs this year, is question answering based on meeting transcripts. And the idea behind this question answering is to provide some personalization. So that also answers halfway, or could be an answer to the question that you, Sebastian, raised. How can we make the minuting useful to very diverse users? So it can be useful because they will ask different questions and they get different answers. AUTOMIN tries to be at least somewhat multilingual in the plans. Although this year we didn't have any Czech related submissions, so the participation didn't allow us to do multilingual evaluation. But we have that at the beginning. So we have two languages, English and Czech, and we have two domains: project meetings, which it's the Elite Meeting Corpus, and then European Parliament, which is a much larger data set, but very particular, both the style of the speeches, as well as the summaries, which are the reference summaries, which are not so much structured. Yeah. So the goal for task A is to create structured minutes from transcripts. I've already mentioned the two domains, and the evaluation. Whenever we are short of money, we have to resort to automatic evaluation. So we use GPT-4 LLM as a judge, as the main authoritative measure. For question answering, maybe Laurent, you could present the task in detail.
Yeah, so it's a new task that was introduced this year. So the idea is to be able to ask questions about meeting transcripts and get some answers. So what we did basically is that we enrich the Eliter meeting corpus with some Q&A. And we did that because we thought it would be a good opportunity to assess the LLM's ability to summarize, but also retrieve information from long context. Because just some time ago, not so long time ago, there were very few large language models with long context beyond 16K. And 16K token is basically the length of a 1 hour meeting. So now there are many more, but at the time we started to annotate the highlighter, to augment the highlighter data set, it was not the case. So this task is only for the project meetings domain. We have mono and cross-lingual settings. So the monolingual setting is just asking a question in English about a transcript of a meeting in English. And the cross-lingual setting is asking a question in Czech about a meeting which is in English and get an answer get an answer about this. And for evaluation, again, we are also using LLM as judges based on the reference answer. So we have reference answers for our Q&A data set, and we provide a numeric score by using a scoring rubric, and that is put in the context of a LLM. So we are following an approach by Kim et al. 2024, but also we consolidated and adapted this to our specific meeting data set for a publication that was presented at the calling conference this year, or last year, sorry. Early this year. But the reference here is 2024 because it's an archive paper. And so we basically give a quality score from 1 to 10.
Yeah, thank you. So here's a brief summary of the data set for the basis one that serves as both a task A meeting summarization data set, and also was the basis for the task B for the questions about the minutes. And it's Czech and English data set, project meetings. There are reference minutes created multiple times, which we didn't really use much this time, but it's good for qualitative research, and the data set serves also beyond our project. And I'm very happy to hear that Felix Schneider and your other colleagues used that also for the evaluation paper. So I'll definitely have to look at that. Here is the illustration for the question answering data set. So maybe again, Laurent, if you want to highlight something.
Yes, it's just an example of question that augment the editor dataset. So for instance, we have those kind of questions and answers. And we have two modes that you can see on the lower part of the block. So we had what we call the Q&A mode, which was the one that was used for the shared task. Q&A means that all the questions are completely standalone. So with the meeting transcript plus the questions, you can actually answer. But we have also this conversational mode where actually you have the full history of the conversation, and you need the full history of the conversation to be able to answer, because maybe the question is referring to some previous words that is referred to. So you have the examples here. But for the benchmark here for the shared task, we use the Q&A only. But the data set is also coming with this conversational version, which could be interesting for the future.
Thank you. There, for the submissions in task A, unfortunately, we only had one submission, and it was the hallucination indexes team. I will not discuss their submission because they are here and they'll present the details later. And we complemented that with the baseline. The baseline was GPT version 4 from this year, and it's actually technically the same GPT-4 as we used in 2023 with this very same prompt: summarize the following project meeting in 5 to 10 bullet points. But the results of the outputs, of course, differ, and that's why we added this baseline. For task B, Laurent?
I can go ahead.
Yes.
So we had two participants this year, so same as André. I will not detail them because they will be presented very soon. But yeah, I just want to add that we also added some baselines that simply involve prompting different LLMs with the meeting transcript in the context. So yeah, just some simple baselines to compare against, and we tested them with different base model.
Yeah, thank you. the evaluation for task A used the same criteria that we have established in the first year already, and then we continued in the second instance. So it's the adequacy, fluency, grammatical correctness, and relevance, where the fluency and grammatical correctness are kind of easy to achieve, especially with LLM-based systems, and adequacy and relevance are related to the content of that. And I'll have one more slide on adequacy and relevance. But as said, we didn't have any funds for manual evaluation, and we had the only single participant. So in order to make something out of it, to make the overview paper interesting, we also include the 2023 systems and experiments with LLM-based an experiment with LLM-based evaluation. So our set of systems that we consider this year is 2023 systems plus the one submission plus GPT-4 run again. For the automatic evaluation, we, as said, rely on GPT-4, and that has improved between the 2 years internally. And we also try to improve the prompt. We moved to the chain of thought, including this feature, which is called reflection. So towards the end of the prompt, we actually ask the system to like reconsider its score and to check if it couldn't be raised. So if the score is adequate, if the model is confident about it. And this reflection is just some more words in the prompt. It's nothing very fancy. So in order to compare the different GPT-4 based evaluation, we have three things to compare. The most recent one and the one that we would like to promote, but like watch out for the results, was this change of thought evaluation done by GPT-4 this year for extraction of the actual values, the assessment. We use these function calls again, which is again just some more words in the input to the model, and that helps the model to produce somewhat formatted output. So it's easier to extract the values, but it's not real any function call. In the previous instance of AUTOMIN, we have used something which we call simple AFGR, so adequacy, fluency, grammatical, and relevance prompt. And that was a simple prompt that asked for these four scales, four scores in one go. And we have these AFGR scores for the older systems from the old instance of GPT-4, and we have a new run with the current GPT. The very same prompt. There is a little catch on the final scale between like 1 and 0 and 10 and 1 and 5, and we just linearly rescale both of them to match the same scaling as we use this year, but that's just a linear transformation, so it should not play any big role. Here are the results. I will not go into the details on the results very much. You see the old 2023 systems, and then you see the 2025 systems. Unfortunately, the single submission here scores pretty low in all the scores compared to the previous systems as well. The reason is probably related to the length of the output. So maybe we'll hear some details from the colleagues. And GPT-4 this year actually produced summaries that were deemed slightly worse than the summaries which were created by GPT-4 in 2023. So it's 2025 evaluation, and the 2025 evaluation likes the 2023 outputs somewhat better. This was for the project meetings, the elite meeting corpus. And for Europarlament, the situation is not very different. The scores for hallucination indexes are somewhat higher. So maybe here are more of the named entities, which is the particle aspect that hallucination indexes focuses on. So maybe that's where they get some gain. And also GPT-4 seems to be better this year than it was. Okay, this maybe there's some glitch. I'm not sure. No, okay. So there's some mix up of GPT-4 outputs. And I'll talk about this later. So GPT-4 worked reasonably well for elite meeting corpus this year. Yeah. Okay. What is the interesting part? And I'm getting to run out of time, but I'll still go over this somewhat, is the correlation of these diverse evaluation methods. So this is a huge correlation matrix. Each cell displays person correlations of scores by different scoring methods, including the old manual scores across individual meetings. So it's more data points than just the number of systems, and that's why I'm mentioning this. So it's the different meetings, whether a particular meeting was scored the same way by GPT-4 or manual GPT-4 this year, GPT-4 in 2023, manual adequacy, manual fluency, and so on. I'll do some zooms into this matrix now. So the first zoom I would like to bring about is the manual scores. It's based only on the old data, but recalculated like this time. And it indicates that adequacy and relevance are difficult to tease apart for humans as well, because the correlation between these two scales is 0.8. In our wordings, we hope, but we are not sure if this really works for people, and we are not sure if it works for LLMs. We hope that people would see adequacy as a recall-like measure. So do the minutes summarize all important things, or is something missing? And relevance should be precision-like. So is it the relevant parts that is summarized as opposed to summarizing something like small talks in those? But maybe this is not highlighted enough, and precision and recall in general like need not be very different unless the system is like heavily optimized towards one of those. So this correlation could be also an acceptable thing. Now, the relevance and adequacy are correlated even more in the automatic evaluation. So where humans, this D is like document level relevance by humans, and document level adequacy by humans. This is the 0.81 as was shown on the previous slide. The corresponding adequacy and relevance established by GPT-4 in 2023 is 0.97. In 2025, chain of thought reasoning, again 0.97, and the simple prompt in 2025, 0.99. So for GPT-4, in both the years and both the simple prompt and the chain of thought prompt, it was very difficult to like make a difference. So humans do make some difference between these two scales. Overall, whatever variant you use for GPT, the scores are correlated, and the higher person correlations are especially for the adequacy and relevance scores. The fluency and grammatically always are somewhat lower. And two more zooms from this zoom. The first one is looking at GPT-25 evaluations, and we see that there is really no big difference between chain of thought and the simple prompt in our evaluation. So as said, the grammatically stands out, and it's somewhat lower, and fluency is somewhat lower because, of course, grammaticality is not too similar to the content measures. But whenever you ask about the content measures, which is relevance and fluency, these scores, these correlations are pretty high. On the other hand, comparing the simple prompt used in 2023 and in 2025, we see that the correlations are lower. So to me, this is a piece of warning again. If you think that you have set up your prompt in a way that you trust, the underlying large language model may evolve in time, and over the years you will have some different results from that. Let's move on to the evaluation of the correlation between humans and classical evaluation measures. This is sad, of course. The best score we have in this part of the table is 0.3 between Rouge 1 and adequacy and relevance. So the classical measures are not really good for evaluating meetings according to our data set and our participating systems. But the worst news is that GPT-25 chain of thought is even worse. So it doesn't even reach this 0.3% correlation, and actually the adequacy and relevance, so the diagonal here should be the highest possible scores, like it should be adequacy measured by humans and adequacy measured by chain of thought, and relevance measured by humans and relevance measured by chain of thought. And the adequacy and relevance are at 0.15 approximately. So that's worse than what we had here with Rouge, right? So I need to finish with something positive. And the positive thing is that we had some adversarial study that happened kind of accidentally. We noticed that the GPT-4 outputs in 2023 were messed up for one of the domains. And it was simply some meeting, and the minutes were misaligned. They belonged to another meeting. So we manually revised these 2023 data, and we use these now manually revised versus misaligned meetings to check if the evaluation metrics are able to identify that the minutes belong to a different meeting, essentially. Because transcript with wrong minutes, of course, should score low in evaluation. So here are the evaluation measures, Rouge 1, Rouge 2, Rouge length, and the different variants of the 2025 scores. And this is the average score that the adversarial minutes get. So you have a meeting and non-matching minutes. So these should be scored lower. And then you have the corresponding regular minutes when we were able to match that the outputs actually belong to that meeting. And the bigger the difference between these, the better the method is at identifying the adversarial examples. According to the Mann-Whitney statistical significant test, this difference is significant between these two groups, even for the classical measures. So that's good, but the absolute difference in the score is there like lower. So for that, just because of the scale, essentially. So for that reason, the chain of thought relevance seems to be the best, the most reliable method to identify that the meetings are mismatched. And it's not surprising, and it's actually kind of a validation that the LLM as a judge does at least something, that the grammaticality is not a factor. So like if you are trying to identify whether the minutes belong to a meeting based on the grammaticality, you cannot do that. And that's a good sign that we failed to have the statistical significance here in the grammaticality scale. Now a quick summary for the task B, which is Thibaut again, I guess.
Yeah. So yeah, I'll try to be quick. Yeah, so basically here on the left, we have the results for the monolingual task, and on the right, on the cross-lingual task. So just an overall view before we dive in more detail. But we noted that the baseline approaches, which consist again in simply prompting LLMs with the full meeting transcript in the context, were the approaches that performed the best on both tasks. So yes, I will detail a bit that in the next slide. So yeah, we can move to the next slide. Thanks. So on the monolingual task, we note that the baselines based on GPT-4o and Llama 3.18 billion performed the best and second best, respectively. And the overall GPT-4o was able to beat all open models by a good margin. We also found that the 5.4 mini instruct model was actually performing very competitively among the 3 to 4 billion parameter models. It seemed to be a pretty strong baseline for its parameter range. Among participant systems, we so the JETL and hallucination indexes team systems scored lower than the baseline, as I already mentioned. We believe that this may be due to the fact that these systems are based on an extractive approach, unlike the LLM-based baseline, that is both less effective for complex questions and also more likely to be penalized by an LLM-based evaluation. And additionally, for the hallucination indexing system, it is based on a model that only allows 1,000 token context, 25, while the transcripts are often longer than 10K tokens. So this could also explain why it was difficult for this model to properly address the full meeting transcripts. On the cross-lingual task, the GPT-4o baseline is the only approach that was able to maintain its performance close to the monolingual one. On the other hand, the open model baselines and the JETARP system show a notable drop in scores compared to the monolingual task. So still some work to do there. And that's it. Yeah, can go ahead.
Thank you. Excellent. So we are now at the conclusions. Again, we think that we did something useful in meeting summarization research. We have introduced the new track of question answering, and we have seen that there is some work to be done. The GPT-4 based evaluation for task A gave us some interesting observation. One is that we didn't really see any difference between the simple versus chain of thought evaluation, and we saw a larger difference between the outputs of 2023 GPT-4 and 2025 GPT-4, both using the very same simple prompt. Adequacy and relevance are very close to each other, so we failed to highlight this difference to the systems. And on the evaluation of minuting, we think that it is really far from solved. Classical evaluation methods are not very good, person 0.3 for adequacy and relevance, and GPT-based evaluations, in our case, seem to be even worse than that, getting 0.15 of person. The positive news is that both the simple classical and the GPT-based methods allow to identify mixed up transcripts and minutes. But overall, and that's my personal summary, I cannot really recommend LLM as a judge. So I would like to hear from you maybe in the discussion, like what can we do better? And another general question that we can ask is, what is the future of meeting processing in the age of generalist LLMs? And that could kind of lump together all what Sebastian was presenting for the unified approach, because all the tools that Sebastian mentioned in principle could be done by a generalist LLM, and it's a question whether the specialized approaches are better or worse. So with that, I would like to just thank to all the participants and fellow organizers, and also to our sponsors, which is some grants, the other project and our OPEAC grant. So thanks. And if you have any questions, please ask them now and quickly, and then we'll move on to the following presentations.
So there was a question, there was a point about there's a degrade in the numbers you see with 2023 GPT and 2025 GPT, right? So my point was, did you see that there was any difference in the deterministic behavior? Like say when you give a same text, because my personal understanding is that GPT always gives me again a variation of the result when I ask it the second time than the first, right? Always it's a little bit of undeterministic about what it can give at the first shot. And do you think that could also be something which could change the numbers here?
That's a great question. I don't know if Kartik can say more about that, because of course it costs money to run GPT-4.
Yeah.
So I would like to do this in more like more instances and see the variance there. But we didn't get there for various reasons. And also I need to apologize that the paper summarizing these results is not yet out for you. We need to polish something, so we're happy to put
this morning. We shared the PDF this morning, but very
yeah. Yes, exactly, and it doesn't include for example, the highlights on of the correlations yet. So there will be version 2 of the paper coming soon. Yeah. But Kartik, Kartik Shinde, maybe would you have some comment on the variance from your experience with GPT-based outputs?
Yeah, so as far as I have observed, in using LLM as a judge, I've seen that the score ranges really matter over here. As in, if you end up giving a really small range of scores, let's say 1, 2, 3, as in good, moderate, and bad, you might not see as much variance in your repetitive calls. But your score ranges, if they vary in hundreds or multiples of tens, it really comes with a lot of variance. And the only way to stabilize this variant is giving the LLM, or here the actual instruct tuned LLMs like Llama 13 billion instruct and similar versions, even Mistral instruct versions, is you tell them how to evaluate the inputs exactly. So you give them a rubric, as in with a score range, say 0 to 2 or 0 to 3. These score ranges should be given 2 minutes that look like this. 4 to 5 or 4 to 6, 4 to 7. These score ranges, the minutes should look like this. If you observe anything that falls in this ballpark of aspects, then only you can put that in this bucket, and internally you are free to choose which score to give. Uh, so based on this, you can sort of cat treat scoring with LLM Judge as a categorization problem, where category is score ranges out of your entire scale of scores. From 0 to 10, say 4 score ranges, you treat it as 4 different categories. So this is what has helped me stabilize scores over the years I've used GPT and Gemini. But yeah, I'm sure there are more options and more prompt-based options over here to achieve stable scores over repetitive calls.
Yeah, thank you.
Thanks. I just want to say one word to nuance a bit what Andre said about LLM as judge for the track A. For track B, which is Q&A, I think we were quite confident that the LLM judge is good enough, at least to evaluate and rank models. We probably because what we expect is an answer, and we do have a reference answer. And so we in the coding paper we documented we made a study to compute the correlation between human judge and LLM judge, and it was pretty good. So just for ranking system, I think at least for track B, we believe that LLM as judge could be improved, but are already useful.
Yeah. Okay. Thank you. So, short of time, I think that we rather should move on. So, I'll
Yes.
stop my sharing. And the next block is now the system presentations, right? So, Gabriela or whoever from the GetHelp team, if you can quickly summarize. And if you could try to save some time, it would be helpful. But there is some slack time at the end. So, I need to apologize before you start. I'll have to leave at 5 o'clock sharp. There is 15 minutes reserve at the end of the slot. So
Yeah.
we are still not running very bad. But
We are good because we are skipping the break. So
yeah.
please, Gabriela, if you can
Yeah.
share.
Okay, so I will share my screen now. Can you hear me? Yes?
We can hear you well,
Yeah.
but we don't still see the screen sharing. Yes, now it's coming.
It's not that, obviously. Here it is.
Yes. Perfect.
Okay, so I will be presenting the our systems that we submit to the task. It will be me and Yongwoo Kang. She will present the second part of this of our participation. We are from the GetAlp team. It's a research team from the informatics laboratory in Grenoble, France. We are postdoctoral researchers and PhD students that use this task to put our research a bit together and like to collaborate each other. So what we will see is a set of techniques in a RAG system, in a retrieval augmented generation system that we developed to answer the task B. So we already had an overview of what task B is about. In details, we have here a meeting the transcript of a meeting, a long document. We have a set of questions that we need to answer, and we have some reference answers. The questions that we need to answer are in different type. It could be how many, who, what questions. So there's this classification. And the answers, sometimes we need to answer a long answer, or sometimes something more specific, as here, that we only need to provide who is the person doing something. Our solution is about a RAG system, retrieval augmented generation, for the question answering. So the first part is related to creating this information retrieval system from the meeting transcript, and then we build this. With that we build a context that we will prompt along with the question to an LLM, to a large language model. So here we will get our system answer. So using this framework, we are going to propose 3 systems. The first one is only with the relevant passages that we are going to retrieve from our information retrieval system. We put that in the LLM and we have our answer. And the second part is about creating some more structured information, trying to get which are the relationships that exist inside these relevant passages, and try to see if we get some different answers, and if these relationships are improving the answers in the system. So as we want to understand if this structured information is important in the LLM generation, we will also generate a third system that contains only the structured information to get an answer. Okay, so as the base of all our system is a RAG system, so we will always have the relevant passages. We need to extract them always. So what we do is trying to represent the meeting in different formats and retrieve the most important passages in the meeting, gathering some relevant passages and go through the LLM. So going into detail on how we are going to represent this document, what we do is to do 2 representations. First, in the sentence level representation, so we compute embeddings for each sentence and we index them, and we do a second representation that is a query representation. So we use the doc2query method, and here what we do is to get for each chunk, we divide the meeting in small chunks, and we will generate some queries that answer this chunk of the meeting. So then when we retrieve relevant passages, we're going to compare a question versus a query, and also we are going to compare this question versus the sentences. So we have these 2 kind of representations to gather to retrieve relevant passages in the document. So we have that, and we include some criteria. So we are going to retrieve from both indexes the 5 most similar sentences and the 5 most similar sentences related to the similarity of the question versus the query. And then with the relevant passages, we are going to extend each of the sentences that we have retrieved to some window. So we noticed that we were retrieving similar sentences to the question, but the answer sometimes was after this similar sentence. So we extend each of the retrieved sentences to include some context, like 3 extra sentences previous and after the most similar one. Other thing that we did was to, even if the most important chunk that we retrieved was the last one, we keep it in the last part that we will present to the LLM in the context. So we preserve the order of all the sentences just to preserve the temporality of the meeting. So all these, then what we have is to using these relevant passages that we retrieve using the IR system, we submit that, we issue that to the LLM using the chat template. We describe the task, and then we also we try different versions of this prompt. We defined that the best way was to present also some rules, like to constrain a bit how the answer will be generated. And in the case of the check, we add at the end the sentence answer in check just to do the answer in check, but we use basically the same pipeline in English all the way through. So this is the IR only. This is the base of all our systems. And then for the second system, we will include some structured information based on the same relevant passages. So it's now Jung who will continue the presentation.
Thank you. So we, as Gabriela mentioned, we'd like to integrate structured information to our Q&A system to see if it improves the results. And we used a particularly abstract meaning representation, AMR in short. AMR represents meaning of a text in a structured format, routine directed graph. And here you can see an example of an AMR graph for the sentence, the workshop takes place in Avignon on August 28th. As you can see, the root node is take place, the main predicate of the sentence. And it's connected to 3 other nodes, workshop, city, and date entity. So, and each edge is labeled. And you can see between take place and workshop, we can see the relation type is arg1. It indicates workshop is the subject of the predicate take place. And the location relation tells where the event is happening, and the time relation tells when this event takes place. So there are many researches that have shown that integrating such an AMR benefits various NLP tasks, such as question answering and automatic text summarization. So our research question is whether integrating AMR into our Q&A system based on LLM read reg improves the results. So this is how we integrated our AMR into our Q&A system. So there are retrieved passages that are extracted from information retrieval step, as Gabriela described. And we generate an AMR graph for each of the sentence in this retrieved passages. And we feed this AMR representation of the retrieved passages along with the question to LLM so that LLM generates an answer to the question. But instead of giving the AMR graph directly to the system, we translate the AMR graph into natural language description. This is because according to Zhang et al., feeding structured information directly to LLM does not improve the result because LLM is massively trained with human language. So it is better at handling natural language description. So following their research approach, we translate an AMR graph into a natural language description. I'm not going to get into the details of how we translated an AMR graph into a natural language description, but if you have any questions, feel free to ask at the end of our presentation. So to evaluate our model, we compared 3 different models as a reminder. The first model receives as an input context. IR-only model receives only a retrieved sentences as an input context. And the second model receives retrieved sentences and its AMR representation. And the third model only receives AMR representation of the retrieved sentences without the original sentences. So the second and the third models are AMR enhanced models. And we evaluate the 3 of our models with LLM as judges. So it shows the results of IR only, IR plus AMR model, and AMR only models in order. And our results showed that unlike our expectation, IR only model performed better than AMR enhanced model. And here we're showing the result for English only, but we conducted the experiments in Czech, and it showed a similar pattern. So IR only model performed the best compared to other AMR enhanced models, but the global score was just lower because we used English model. And we also took subsamples of the test set and evaluated the model's prediction manually. So, and it also showed the similar pattern as LLMS judges. IR only model performed the best compared to the AMR enhanced models, but the global score was higher for all the models with human evaluation. And we looked into the predictions of the model. So for example, for each of the example, you see question and the ground truth and the predictions of IR only model and IR plus AMR model. So here for the question, when should the data be ready? IR only model correctly found the relevant information from the given passage, but IR plus AMR model could not find the relevant information. And another example it's an example of a what question. So IR only model correctly answered the questions, and IR plus AMR model partially found the correct information from the passage, but it unnecessarily added unrelevant information to the answer, which degraded the quality of the answer. But we noticed that for all different question types, AMR enhanced model worked better for who types question. So for this who question, we can see that IR only model, even though it correctly found the answer, it only added another information to the answer, whereas IR plus AMR model precisely found only the necessary information. And this is another who question example where it shows IR plus AMR model performed better than IR only model. So as a conclusion, we suggested REG combined with AMR for Q&A task. Even though our results showed that IR only model performed better in general, our results show that IR plus AMR model worked better for who types questions. So based on these results, our future work can be selectively adding AMR representations only to who questions that benefited by adding AMR representation to the input context. And we could also work on refining the AMR to natural language translations to improve the quality of the input context. And to finish, one of our limits of the work is that our experiments required high performance GPUs such as NVIDIA A6000, which has 48 gigabytes of RAM. Thank you.
Thank you.
Thank you very much for presentation. So are there any questions from the audience?
I have some.
Yes, please do.
Yeah.
Go ahead.
So in your experiments, you found that IR plus AMR does not consistently outperform IR only, even though AMR should, in principle, help with the semantic disambiguation of participants and of basically participant role resolution. So, do you think this reflects limitations of AMR to text conversion process, or maybe where do you see the bottleneck over here? Is it in the representations itself, or is it the fusion strategy within the RAG framework?
Actually, one of my hypotheses about inequivalence among across types of questions is that the parser, AMR parser that we used. So we didn't have time to look into the details of so we first generate AMR graph from retrieved sentences, but it's possible that and for AMR generation, we used an external API. So it's a trained AMR parser. But it's possible that this parser was more correct for capturing who did what than other part of information, like how it is done or when and where. So I think this could be possibly the reason why it showed better performance for who type question. But to confirm that, we will have to look into the predictions of this AMR parser more in detail.
Yeah, all right. Thanks.
Thank you.
Thank you.
Maybe, sorry, as a follow-up on this question about AMR, I was wondering if you think it's possible to have a kind of hybrid adaptive approach that automatically verifies the quality of the AMR graph and then only uses it if it's correct. Because as you say, it seems that in some cases it would help, like for the who questions. In some other cases, maybe not so much. So maybe that would be worth having, like using it only in the cases that the AMR graph is actually bringing something correct. Yeah.
Yeah, I think it's a really, and that's something that we'd like to do. That's why the selectively adding AMR only for those questions that can benefit from that.
Mhm.
But but like how we choose, how we know like which kind of question benefits the most, and how we selectively integrate them to the system is still in question. Yeah, for now, based on our results, we know that it improved who questions, but we will need more analysis to be able to do that, to integrate like selective integration. Thank you.
I also agree with the remarks of the overview that we use some only extractive techniques. So we add a lot of noise to the context also with the IR and with the AMR. There are a lot of relations described there that are not useful for the LLM actually.
If I may, also a follow-up question on the AMR. The way you use it by converting the text into the AMR graph and then synthesizing text back, essentially AMR works as like a coarsening of the message. So have you checked what is lost or what is distorted? And that could be kind of the basis for what was suggested here, that you should have some confidence about the AMR being good. But just visually inspecting what the AMR spoken text looks like. Have you seen anything systematic that's worth commenting on?
So we basically just followed the article that I presented earlier. Other than that paper, I do not know if I do not think that there is other work that systematically translates or there are other like approaches that generates text from AMR graph, but it's different from our objective. We really wanted to integrate semantic, like structured information to the system, but in an optimal way for LLM. But those AMR to text generation are more like they more focus on how to generate a like complete sentence from one AMR graph. So.
Yeah, so essentially what one could be asking, there could be, for example, and I don't know if that is happening, there could be some LLMs involved in polishing the sentence using the AMR to text synthesis. And then one could ask where more information is lost or distorted.
Yeah.
Is it when you are creating the graph from the text or when you are expressing the graph in text, into text again? So these two separate steps can be, each of them can be separately more detrimental than the other. But I was curious, just in general, whether you have looked at the AMR-based text representations of your snippets.
I only could see subsamples of examples, and sometimes, as you said, like the information was lost. I didn't really measure at which step the information was lost and at which step information was lost the most. But it could be a really interesting direction. Yeah. Thank you.
Yeah, and thanks very much overall for this contribution, and also for using AMR. I'm like looking forward to other results with that, because I've worked also a little on the structured representation of sentences, so I'm fond of that.
Great, thank you.
Okay, any more questions? If not, then I suggest that we move on to hallucination indexes, the other submission.
Yeah.
So Praveen.
Yeah.
Yes, your screen sharing is starting.
Yes. I'll just go into the slide mode. Okay. I hope I'm audible to everybody. Yeah.
Yes, and now we also see your slides. So
yeah,
thank you. Please go on.
Yeah. So this is our main contribution is about the entity hallucination index. Okay. We will discuss about that. So we have some. It's as part of my PhD, part-time PhD research, and I work in an organization separately as a part-time researcher as in the university for triple IT. And my research includes, working on NLP and working basically on the evaluation aspect itself. And I did perform a review before I started my research, and there was a lot of summarization related problems. And one of the things that came in most predominantly is the hallucination. So because until then, when you make more abstract, you are bound to hallucinate, and some hallucinations are useful and some hallucinations are not. When I say hallucination, something that did not belong in the input text, but it's going to come in your output. But it may not necessarily be a bad one, because even when you ask, let's say for example, if you ask a sport person to summarize a news article, and you ask a advocate or a lawyer, a legal person, to summarize a news article, they both will summarize the same article in different way because of their knowledge, and they would abstract it in their own terms and then put it out. Then there is, of course, there is going to be a change in the vocabulary they use, and also it's going to be change in the way they prioritize the focus, right? So they focus on certain different things, right? So that kind of challenge exists, and we see that when most of the systems are still backed with, because you have a good evaluation when you have a reference, as I said, but without a reference, it's still a challenge. And even our tool doesn't give a right solution for that, but it does give some inputs on how there might be a possibility to validate it. So before we move on, let's first try to define what is the hallucination thing, right? So let's say you have a t text which is containing some tuples, right? You will have even entities and relations, because that's what makes sentences. So you have entities, you have relations R, and then you have generated summary S set, which is again going to be a set of entities and relation. And then you are going to try out what is this. Like if your input text, now you put up a relationship between your the entities that are present in your original content and the entities that your system generated. If they are supported by your original sentence, yes, then you are not hallucinating, otherwise you're hallucinating. So the FET is actually like a inverse of that. Okay, so the function which we see, because we want faithful. So this definition is actually the faithful definition, not the hallucination definition. But we want to tell that what you are not doing is actually the hallucination part. And similarly, this is for entities, but there's also a scope for the relation thing. And I think after looking at Gabriella's presentation, I do believe that AMRs can actually help there for as well. So then we have generated summaries that contain incorrect, fabricated information that is not present in sent, and we predominantly have been looking on ways we can come out with, and meeting summarization is one of the things. So news articles is one other thing, medical reporting, financial documentations. So a lot of aspects are there where summarization is needed, and these hallucination causes a problem, because of which, even though there is a solution which says on the benchmark that, hey, it's performing good, it may not be suitable for your real world application, right? There's always all organizations do handle the models with a caution, because they cannot completely believe that it's right or wrong, because the hallucination makes it look like a good one, but it may not really be. And that always adds up a challenge. And of course, these are the three current limitations that exist in this thing. And what we wanted is, one of my references that I had also talks about the hallucination taxonomy. So there are different kinds of hallucinations that exist. Okay, so you can see in the table are the different types of hallucinations that you can have, and there is always an example for that. But when we looked at it, we tried to focus on the granularity one, which is the entity, relation, and fact level. So we are so there's another aspect which I think from Krasinski, there's a fact level thing. They do fact CC evaluation. Okay, but we have built over on entity. So we say, hey, if there are some entities in your reference and there are some entities in your input, then we try to bring out some entities that are necessary to keep your things valid. Okay, so that's where entity hallucination comes into play. But before that, when our research, we also realized there are main important thing is, there are a lot of models, and you can use different kind of, even today we have a new option of LLM as judge. Then there are other aspects as well. The reason why Rook scores have been the state of the art for a long time for evaluation of text is because they are very simple, automatic, empirical nature, right? So that kind of feature, I don't think today even a lot of other metrics are providing. Even BERT score has some dependency, and there are aspects, but yeah, we do see that, okay, something like Rook or something, which does with the existing information. You do not want to rely on any on the outer world aspects to evaluate something. And then we found out there is one metric which is closer to this, is the entity F1, which tries to see what are metrics. It's just a F1 calculation of entities that you saw and entities overall you saw. Okay, and try to give up answer for that. It tells you what is good, but if there is something wrong, it doesn't beat the hallucination. It beats the it actually beats the adequacy, but it cannot give you the the precision that you want, right? So it will have so let's say there is an example of some content which was there in the input, but that is not necessary to be part of the summary. It comes in, then your system is still gonna get a good EFN score, but it's actually not the good one. So there is a need for some evaluation metric, something like Rook, which can solve the problems of finding out these fabricated wrong missing entities. So we researched on that part, and this is the main Venn diagram. I mean, this diagram is the core of the entire work we have done. Okay, so when you are actually doing let's say you have a reference set in that scenario. Okay, there are two scenarios. One will be with reference and without, but here we say if you have a reference. So you have an input, you have a reference, you have a system summary that you have, right? And what are things that you can categorize into? So if you have a content which present in your input, it is present in your reference also, and even the system is having it, then we call it as an extractive, right? It's basically nothing, but it's just passed on to the original text to the system, right? But there are cases where you will see the reference is talking of some aspect which is not at all present in the input. Okay. So let's say the input contains something about football game, and then there is a penalty stroke or some word which is not given in the input, but you can see that it's part of the reference because somebody who made the summary in the reference knows about the football game, and he talks about some terminology of football which is totally not present in the input text. Now, the system, when it has to generate, if it has to generate, it also needs to hallucinate, or it also has to generate some words which are relevant to the reference, because that is what is the abstractive summarization means, right? You will have to bring up it in own words. You will have to bring it on new words, new vocabulary there. Now, these words choice is actually something. If it is able to do that same thing which your reference summary is doing, then yes, it is positive hallucination because it is not present in the input, but still you are generating it somehow, you got that word out, right? That's a positive hallucination because it is improvising you the solution. It is improvising your summary. Whereas other parts, which are like the input is having it, okay, the reference is also having it, but you did not pay focus to that, you missed it. And that's going to be your system summary has lost. That is what is lost focus. And the other hand, you have something like as you have over focus. So the input is having it, but your reference is not at all related. As I gave the example earlier, let's say a advocate does about a sports article and a sportsman reads a sports article. Their focus is going to be totally different. Now it is who has written the reference for you is going to be the choice here. Who is going to focus, right? So let's say the reference is belonging to an advocate's focus, then definitely you have given a sportsman's focus, then you are gonna lose the context there, and you will have some entities which will be missing. So it can be for entity, it can be for relation, but in our this system particularly, we focused on entities this time. Okay. So that's all covers the most of the thing, and that's what we compute here. And then we give a exponential formula here for our EHI, which is going to use these kind of five factors. Okay, we consider these as the five factors, and we calculate them. So I is the entities, R and G are the sets of entities for each input, reference, and generated summaries. Okay, and similarly we have EHI, which if you see on the numerator, we keep the positive hallucination and the extractiveness factor. That is because this part in the extractiveness and positive hallucination is what we want. This is what the summary needs to be focusing on, right? So that's why those are like good ones. And the other ones, the negative hallucination, the over focus, and the lost focus, these are the ones which needs to be punished. I mean, these are the ones which we do not want, right? You lost something, you misinterpreted something, and then you overstressed on something, right? So these three things are not needed, and we need to get away from them. So we put those things together, and then we compute this EHF formula like this. Okay, that's how the derivation of this entity hallucination index comes. Before applying to AUTOMIN, we did have some because we generally we propose this EHI as a detection mechanism. This is the first time that as part of AUTOMIN, I tried to use it like a solution because I try to see that if we can actually use EHI based system to improvise the output on any existing models. So that's what we did. But we did had some past research which we have where we computed summary for all of this, and we calculated the metrics, and then we have put a presence on that. This is what we have. But yeah, before that, I wanted to point out one more aspect is that we calculate the entity sets, right? But the entity sets is coming from generating NER model. So we choose the NER model and we make sure that the entity set is present before we calculate those formulas, right? So that is the only outside external entity right now we have, okay? And we do see that NER models are pretty mature, but then in this particular AUTOMIN, we got to know that Spacey is not so good with this kind of data set, especially the meeting transcription data set, okay? So, and we could have used some other metric like BERT NER to figure out more entities. As you can see, AutoPAL had better entities than compared to the another data set, and that's why the results were varying across in the task A. We'll come back to that again. And this is for our correlation for which we did for the earlier research also. Here we wanted to show it like how the factors play around, and there is always a negative correlation between the EHI and these other three factors, and the two positive hallucination and extractive will be the positive ones. And what you can understand is positive hallucination is actually matches with the entity F1. Okay, that's because positive hallucination is actually entity F1. Okay, so that's why we derived this same thing with a different approach. But apart from that, if you see the focus, not we need to also make it accurate, right? So to bring it accurate, we need to get rid of these other three factors, and we try to automate on those aspects of it, and that's where this entity H1 EHI metric comes in. We also had this done for Hindi, and we came up with another method of evaluating our EHI model itself, how the evaluation works. The best way to evaluate a evaluation metric is doing right or wrong is to use the reference itself as the generated model output, because that will tell you how the how your evaluation technique behaves when you actually give when you actually give the same reference, like you give like you are giving 100% answer, right? So if somebody is doing with an overlap, then definitely it's going to help. But apart from that, there's also a way, even for LLM as judge, right? I mean, I did think that probably we could see, along with those outputs that you have, if we have an output of the reference as well, if there was a reference available, yeah, probably we could put that and see how the evaluation is actually doing. Comparatively, we had these four models we had put on, and then the outputs of these were calculated for us, and we put it. And now let's coming to the fine tuning. So the fine tuning was pretty simple. We didn't we just tried to penalize the system based on the EHI score. So we take the EHI score, and if the EHI is improving, that is, it is going beyond a certain value, 0.5 or so, we say, okay, it's improving, right? And we expect the entity hallucination index to be higher, so that it is actually the output is pretty good, because we add something, because if we see that the numerator has to be big, right? So if the numerator is bigger, that means your positive hallucination and your extractiveness factor is good, right? So we try to pull that one. So based on that, we try to apply the reinforced algorithms. It's a simple gradient algorithm itself. We just calculate it on every output of the summary. We calculate the NER, we get that NER output, give it, calculate the formula, and then give it to the iteration again to see whether we have improved it or not, and we trained it on for a set of models. So we did train on T5 Mistral, and these are the parameters we have set for Mistral and T5, which we can see here. And the learning rates and the optimizers that we use and all the hyperparameters that we use for this session. These are not something new. This is anybody who does fine tuning has predominantly would be doing the same configurations only. It's just that we took the one which works based on the available collab credits that we had, and based on the GPUs accessible to us, we could actually do this part of training done. Okay. Now coming to the results, what we had gotten, right? So we had, of course, two tasks, right? So 80, 10, whatever the instructions were given to us, we went through them. And I think these are the ones which we got from AUTOMIN. So how we did was, as you know, right, this particular the importance of my paper is that we are not doing anything on the model as such, because I'm looking for a method rather than a model. Okay, I'm not looking for a system, I'm looking for a solution or a approach to solve that. Okay, so that's why I was looking for something to be a model agnostic. I do not want, today GPT is a good model, but tomorrow you might have something else, and we do not want we could simply adapt to the evaluation, right? We could simply choose it, make it work, and move on and use it in applications, right? So based on that approach or that thought in process, I had prepared this kind of steps that we wanted to perform. Like we go for any model, if you can bring down the hallucination in it and can use it, make it usable, it's pretty good enough for us. So that's why nothing has been changed at the model level, apart from doing a little bit of fine tuning with the metric based on its scores. We trained it for 80 items, and then we asked to validate on the 10 items, and then we evaluated on the 10 items further on the test, right? So we cleaned it, and we cleaned the transcripts. A bit of cleanness was done, and then we also did some preparation with respect to the 1024 tokens limit. So we did perform chunking, but I do believe that there was some issue with our chunking mechanism, which also explains some problem going on. But yeah, it's something we had a work in progress. Because of the time constraint, we did have we had very less chance to fine tune it again with a better chunking solution. Okay. we generated the output of the 4 models separately, and we stored the result with the original transcript and summary reference minutes, and we evaluated our EHI metrics for our reference, and then we sent out the JSON results for the each test as was asked for the task here. These are the results that we
Sorry,
were.
sorry. Do you think you can conclude and wrap up in 3 minutes? Because we are running out very late.
Sorry, I didn't get the question. Correctly.
Yeah, I was asking if you can wrap up in the following 3 minutes. Is it possible? We are
Yes,
running.
yes, yes. Yeah. I think only 3 slides are more.
Okay, thank you so much.
Yeah. So the AUTOMIN and the Europarallel set, these are the results we had, and yeah, the digital some Samsung, and this is predominantly because the AUTOMIN ELMI seems to had more of a pronounce, and I think entity NER models don't work more on that, and plus we had the SPACY being used, which could have been better if we had used a transformer based NER, but transformer based NER is little more expensive in computation compared to the existing system. So then we did a comparison of entity F1 with the FLAN-T5's output. And predominantly positive hallucination is nothing but entity F1. So we have the EHI actually seemed to be improved because we trained the models based on that. And we could see there was some improvement even for the same results that were used. Which were not part of the training as well. So we could see that the model was actually adapting to some part, like there was some improvement for the same answer, where we could see that the negative hallucination and things were coming down lesser. On the task, we only had FLAN-T5. We could prepare the results for given the time for us, and there, of course, the chunking was a problem. But in fact of that, I could see that for very precise answers, like very 1 word or 2 word answers, FLAN-T5 performed well, but in more elaborate ones, I think definitely FLAN-T5 had its own challenges in computation. But also given that point that we didn't use a good NER model, we didn't use the relation. We only focus on entities. We didn't focus on the relation here. Those are the 2 reasons why it would not be surprised for me to see the indexes in the lower part here. Okay. This is all about the fine tuning. After we did with the EHI fine tuning, how was the entity F1 scores coming and how was the EHI F1 correlation was happening. So the correlation is inverse when it comes to more negative hallucination and the other aspects like over focus and things. Otherwise, if it is only about positive hallucination, then it's actually going to be a non-inverse correlation. So we propose this model, we propose this metric, and we propose this model that we taking any model, we can actually convert it to answer your hallucination problems. But it is incomplete if you do not do it for relation. And I think we need a ER relation model hallucination that needs to be added definitely to make it work. Yeah, EHI is computationally less expensive and can adapt to any domains easily, and it's pretty fast to compute it out as well. Effectiveness of NER model is the choice of the NER is very important because you are trying to identify entities, and if your model is not good enough for that data set, if your NER model is not good enough, then your EHI is also not good enough, right? So that's how the power. I would also like to thank my guide, and I'm pretty much very much of my appreciation goes to Naman, who was the main savior for me in helping me. Given my office related stuff, I was able to get this implementation done, at least to participate in this competition. So very thanks to Naman, and yeah, of course my guides have been always there for me to help. Thanks.
Okay, thank you. I suggest that unless there are very pressing questions, we move right away to the next keynote talk, if that is all right. And Lauren?
For the questions, maybe ask them in the chat, and probably
yes,
best to proceed like that.
Yeah.
Yes, and I will make a quick introduction
Yes.
of Sebastian. And first of all, sorry, Sebastian, to be late. It seems that we need some Zoom AI feature to be the timekeeper because I was not a very good timekeeper. Unfortunately,
myself, no worries.
Yeah, Sebastian Stucker has left, but probably it's a good suggestion for them to build some AI that will be moderate to this kind of workshop and keep the time. So yeah, thanks a lot for being with us, Sebastian. So you're the Pi Schools managing director. So Pi School is in Roma. Probably you will introduce it a bit more. My understanding is it's an innovation center, and you have been working on machine learning and NLP for many years. You're now leading and coordinating this Between EU project that was also mentioned by Sebastian Stucker, and you will probably share some projects results about it. So you have the floor, and thanks for being with us.
Thank you, Laurent, and thank you to all organizers for this workshop. First off, can you hear me well?
Yes, very well.
Super. Okay, so then let's go. And thanks for the introduction as well, Laurent. So yeah, I'm, like you said, I'm both in Translated, where I'm the director of AI, and in Pi School. In Translated, we do professional translation services. We have a very large network of 200,000 professional translators who operate in 200 languages. And obviously, we do machine translation as well. So that means we build our own machine translation, and we work in research on I would say the cutting edge of what translation means. So that's video translation, audio translation for instance, podcasts or video contents. And that's the capacity in which we're engaged in these research projects. In Pi School, instead, we mainly do rapid prototyping in AI. We've got a very specific format that we've repeated 100 times now, where we do sprints of 8 weeks, and we work on business problems that we solve with AI. I'm currently the coordinator of these two Horizon projects that I'm going to tell you a bit more about, Between and Loops. So Between is the one that Zoom Research with Sebastian Stucker, where they're involved as well. And Loops is another one that just started. My background, I graduated as an engineer from École Centrale Paris and did a double degree in speech and language processing and MPhil back in Cambridge. And then I worked in the industry for a bit and went back to Cambridge to do a PhD in probabilistic machine learning at the Department of Engineering with Zubin Garamani. Like many people in the world, I grew up bilingual. And this is why I developed an early interest for language. And I was also very fond of engineering. And so that's the sort of putting things together. This is how I ended up working on NLP and speech. So I see that my slides are frozen and I'm trying to move on with them. Sorry for that. I'm gonna stop sharing and share again. So I'm gonna try and clarify my message for today so that we're all on the same page. So what I'm trying to say, speaking about speech. So speech is one of the ways in which we turn thoughts into language, right? It's intrinsically multimodal because it's a physical activity. So far, technology, ever since let's say the 80s, maybe, we've only been able to process mostly its verbal components, so the words, and this is obviously the most information-bearing part of speech. And what I want to speak about today here is the other components of speech and its multimodal dimensions. So the non-verbal parts that we cannot ignore in speech. Now we've got multimodal foundation models, since about a few years. And so we can now process speech holistically. This is what I'm going to speak about. So this means that we need to view all the facets of speech in perception and in generation. In order to show you what this means, I'm going to draw examples from these two projects, MeTween and Doops. So MeTween is a 4-year research project we started in January 2024, 7 million euros budget. It's got 7 partners, Transited and PySchool, where I work, Fondazione Bruno Kessler in Italy, Zoom Research, Karlsruhe Institute of Technology, TAUS, that's a specialist in language data, Technical University of Istanbul, and Cyphernet, which is the national provider for high-performance computing in Poland. We work on various tasks, and virtual agents for video conferencing are the application mostly. Doops is a project which started last month. It's much larger, it's 4 times as large, 4 years as well. Main partners, also Transited and PySchool, but then we've also got University of Oxford, EPFL, ETH Zurich, and then a host of partners which have some connection with application domains. Okay, because we work on a whole range of multimodal foundation models and multimodality per se. We work on research, on the technology, up to the applications, and we've got application domains. We've got 3, I say 3 plus 2, because we've defined cardiology, geointelligence, and language communication as the application domains that we work on as of the proposal. And then we've got surprise application domains that we'll define during the course of the project in an ad hoc way, depending on scientific challenges, available data, interesting applications, and so forth, which will bring us to a total of 5. So speech, as we know, is not just audio text. That would be too easy. And what's a better way to convince you of that than to show you a little movie that we put together to illustrate the work we do at Translated. It's called Human Touch. So I'm going to play this movie for you here. I hope it comes. So it should come through with the audio. Do shout if the audio doesn't come through well.
Catch on, make sense of it all. You watch and you show, and then you just know. Face to face, when feelings just right. Needs no explaining. I know you can see. Oh, hello, somebody who grows. You see, you hear me, and it makes me glow. I go back the look in your eyes, home by the river, hold me, be my mirror. Love, can you feel me? This is our human touch.
Here we go. So human touch illustrated here. So let's look at what speech is. And when I do this, I often take out this image, which is from publication 2022 about gesticulation to accompany speech. So here we have different levels of what's going on in speech. Obviously, we've got the audio track. At the bottom, we've got the text track. And at the top, we've got what's called gesticulation, which is everything that goes on, let's say, in a video track, that, you know, stuff we could record with a camera, be it one single camera, an array of cameras, you name it. So this is all that goes on with your hands, gaze, the facial expressions, the gestures you can perform with your torso, the orientation of your body, the direction in which you orient your attention and so forth. So all these things, they're one dimensional. There's one primary dimension, which is time, obviously, and so they're aligned. There's some synchronization points between gestures, audio, and the meaning. So sometimes we can speak of speech punctuation, and this is what this means. This is due, the shape, the type of multimodality that we see in speech. This is all due to the fact that, speech is this physical manifestation of language, okay? So if we look at how speech works or how it's formed, well, obviously it starts from the semantics and the form. So the form meaning surface form. This is all that's then manifests itself in terms of prosody and so forth. So there's words, which is the verbal content. And then in a physical performance, we've got everything that comes through the speech organs. So that's mouth and lips and lungs. Obviously, volume is important in speech. And then everything that goes through the rest of the body, face, gaze, gesture, body pose. And this can be captured, like I said, in video. This can be captured as text. And the resulting thing here, this is captured. This is what we often, in a restricted way, we call speech. Modalities, this is all that's going on in speech at the same time. So in the text, we've got everything that's got to do with punctuation and the semantics implied by punctuation. In the audio, we've obviously got the verbals as well, but we've got stuff like hesitations, disfluencies, mouth noises. It might be other things that's not here, non-verbals. It might be yawning, or it might be stuff like fatigues. There might also be background noise, channel artifacts, and so forth. Raveen, I think you're messaging the chat. You're messaging the entire chat. Maybe you're meaning to speak to just one of the persons on the chat. Okay, and this is at the audio level, and then at the video level, you've got all these other things I'm not going to go into details of. So back in 2004, I was working on a project called Agent Conversationnel Expressif back in France. This was joint work with Catherine Pellachot, with Justine Cassel, Marc Cavazza. And so there we were working, I bumped into these notes from back at the time, drawings of mine, and thoughts about NVML being nonverbal markup language, what it means to have emblematics, metaphorics, iconics, all the things to do with gestures. 2006, there was this paper that came out where people tried to develop markup, like these were literally XML markup languages to encode what's going on at the nonverbal level. So there was a lot of work at the time, and this is obviously important to animate avatars, but then also to annotate what humans do and imitate what humans do, learn from what humans do in order to animate avatars in a faithful way. In 2025, now we've got work from the Seamless team at Meta AI Research that's recently come out. This is a Seamless interaction data set. And this is obviously totally connected to what I was working on 20 years ago. This is a very large in-person conversation data set that, documents with a host of annotation, essentially what goes on in two-person conversation. So it's all that's got to do with the multiple dimensions that I have just spoken about in a data set. So it's 4,000 hours of recorded speech participants exclusively in one-to-one conversations. And so they're looking exactly at the same aspects, with new tools and obviously with new models that we were looking at 20 years ago. So this is something that's not going away because this is very deep down what speech is about. Another thing, another aspect where you can see that speech is this very intrinsically multimodal thing that I wanted to show you because it's both fun and really interesting at a deep level. This is a paper from 1976, which is called Hearing Lips and Seeing Voices. It's a paper by Harry McGurk and John MacDonald. So they discovered this effect that I'm going to illustrate in this video here, where essentially we're speaking about phonology here. Your perception of syllables or of sounds, phonemes really, that are spoken depends not only on your auditory perception, but also very widely on your visual perception. So what's going on in this video, I'm decoding it for you because before I launch it, is that the actor here, who's a professional magician, by the way, interesting to look at what he does. The actor here is so essentially it's a track that's made up of a soundtrack, which is the same syllable over and over again. So it's the same sound that you will hear, but with a different visual track that does not correspond, that is not the synchronous recording of the audio track, if you will. And what you will experience if you have, let's say, normal audio visual speech perception, like most people at least, is that you will actually think that you're hearing different sounds. And this is called the McGurk effect, we see after the authors.
Ba 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 ba.
Same audio, different video.
Ba 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 ba.
Same audio again,
ba ba
different video.
ba 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 ba
different video.
ba 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 ba
that you probably
ba
think you're hearing, depending
ba
on the
ba
video you're watching.
ba 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 ba.
Here we go. And the McGurk effect. Okay, this is, it's an experiment. It's a deep insight. It's got they wrote I think it was 2018. They wrote, the surviving researcher McGurk wrote this. McDonald, sorry, wrote this paper to speak of the aftermath of the paper they wrote back in '76, 40 years later. So this is a really interesting piece of knowledge about speech perception. Now, let's expand this view, okay? Less familiar aspects of speech here, but that are still relevant in the view that I'm trying to convey to you. So there's people working on articulation, and especially silent speech recognition, which is important. Where what you're looking at essentially is what goes on at the sort of muscular level. You're measuring with these electrodes here that you see in the picture. This is a project from an MIT student called Alter Ego. This was back in 2018 and so forth, 2019. This MIT student has then founded a startup and so forth. So here, what we're looking at is measuring electric currents that essentially measure the contraction of muscles, which are which move the tongue, the jaw, and so forth. And this is a new set of sensors for speech. So it's a kind of new modality for speech. It's still speech, but it's a new modality, a new track, if you will. Okay, and it's got its own application, because here, obviously, what you can do is you can speak silently, and you can still measure, and you can still reconstruct speech, and that's got a lot of applications, especially in very noisy environments. It's a piece of work, or it's a strand of work that was pretty active back in 2000, in the years in the noughts, in the 2000 to 2010, where people worked on articulators and trying to model. So it's called a dynamic Bayesian network. So it's a probabilistic network. So you've got time steps that unfold horizontally here. And essentially what you model is how you transition from one time step, the state in one time step, to the next, from the left to the right. So you've got kind of Markov chains where the right state only depends on the left state. And you've got some Markov dependencies inside the state itself. And the way the state is described is by the position of the articulators. Okay, so that then what you can do is you can build, and people have been doing this in the past, you can build both speech synthesis models and speech recognition models based on the movements of articulators, okay? Because what is it that causes the sound or that causes the video that you're recording when you're recording somebody speaking? Well, obviously it's the movement of the articulators in part. So here you've got the different tracks that come together. The velum, the glottis, the F0, the fundamental frequency, lung pressure, intensity, the exact movement of each of our articulators in our mouth. And this, this is both interesting for synthesis and for perception. So, strand of work that was going on back then, especially in Cambridge, where I did my studies in the speech lab there. And that is interesting to think about. It's got some repercussions about multimodality or multimodal foundation models these days, because they're very, they're another modality yet for speech. And we can extend this. So I'm not going to go into many details. I'm just going to point to these. There's sign language, okay? Another, sign language is another way of producing language, which is very similar to speech. Because, well, importantly, it's got prosody as well. So the way you sign, the emphasis, for instance, the pauses you do, the face expressions that accompany the movement of hands and arms, this is all the prosody that comes with sign language. And we can go on like this. So if you look at what's going on in your brains, the motor areas in your brains, these are other ways that you can measure speech. And it goes on and on. Now, let's think about the parallels with printed text. Okay, if we look beyond printed text, as in just the words that are printed. Well, on printed text, you've got fonts, you've got typography, you've got layout, you've got word formatting, stuff like italics, slanted, bold. And I think it's inspiring to think of the parallels we've got between printed text and speech. So, for instance, we can think of prosody a bit like what goes on with font and formatting. The timing of speech, so the breaks I do, have to do with layout and obviously reading order and reading speed. Pronunciation or stuff like accents, this has got to do with formatting and emphasis in the printed text. And so, there are people who think of expressive speech synthesis a bit like typography generation or formatted text generation. And if we look at other language manifestations, if you will, handwriting, I mentioned already, sign language, we can draw these parallels as well. So there are people, I'm not going to go into the details of the research here, but there's very interesting work that I try and follow because it inspires my work on speech. Work going on in OCR, so optical character recognition. People, thinking a bit like I'm saying here, that want to have this holistic view of what's going on with printed text and printed documents. And so they're thinking of printed text in the wild. So that's the top row, document printed text, or the splitting up printed text. And then all sorts of printed stuff that is not necessarily only text, but here's sheet music. These are diagrams and shapes, so there's here at the top here, maybe you can distinguish as mathematical formula. So all these things are different manifestations, obviously, of text, very much like we can think of different manifestations of language in speech. There's the more recent work in end of last year and beginning of this year with benchmarks that sort of collect all these OCR-related tasks in a holistic way. And so I think there's a lot of work going on that's interesting to follow. Here's a sample from the very recent Qwen image edit, where the interesting part here is based on an instruction here, make a fashion magazine cover with a woman posing in a red dress. The title of the magazine is Qwen image edit, no other text. Actually, this is cut, and the instruction is not complete because it also says the woman is before the word Qwen at the top and behind Qwen image edit at the bottom. And so you've got this new family of models that can actually do layout and typography in a super fine-grained way that you can address with natural language instructions in a very symmetric way, as we do in Metween, for instance, with our speech foundation models. This is a paper back from 2022 from Apple Research that I found really interesting. Same idea again. They're using the same architecture to disentangle speech style and handwriting style. Okay, so the personality or the identity of the writer, the identity of the speaker, overlay it to the contents of the words, both in handwriting. So at the top right here, I'm showing you what you can do in handwriting. So it's interpolation between styles. So this is one style, this is the other style, and here you've got words that are neither in neither of the references, but you can interpolate between the two. And you can do the same thing, obviously, you know that with speech synthesis. And so the interesting part here is that they're using, well, the same architecture for both handwriting and for speech, which illustrates, I think, this multimodality aspect very well. In Metween, I'm going to go in a couple of details of how we address this in Metween. And yes, Laurent, Andre, I'm conscious of time, so I guess I'm 25 minutes into my talk now. So I'm going to try and squeeze some parts. Skip some parts, actually. So in Metween, we address many of these things. We work on audiovisual speech recognition. So this is work that Alexander Weibel and colleagues do at Karlsruhe Institute of Technology on cocktail party audiovisual speech recognition, where the idea is you enrich the speech segmentation, the diarization, and ultimately the recognition by informing the processing with visual information on top of audio information. And an important ingredient here is the AV Hubert audiovisual encoder. And so there's a lot of work that we're doing that relies on having modality-specific encoders here. And what they demonstrate in the paper, obviously, is that it's a very recent paper from 3 months ago, is that the visual information is very important, especially in the presence of noise, to get the segmentation and ultimately the recognition right. We work in the project. We also work on talking face generation from still images and audio, and so we've got people introducing new ideas here. This paper here from Alex as well, Hazim Ekenel from Istanbul, and colleagues. This is work where the strong idea is they introduce synchronization loss between the audio and the video channels. So that, you can see here in blue, this is a combination of losses that makes the thing work. In Metween, we also work on benchmarks, and so we've produced this MCIF, multimodal cross-lingual instruction following benchmark, a very big one that covers very much all the ground, like all the tasks they're interested in, under different modalities, multiple tasks, based on material that is scientific talks. We produce a couple of models as well. So one here is from my colleagues at Fondazione Bruno Kessler called FAMA, which is very interesting because it's very strongly open science, so open everything, not only weights, but also recipes, data, and so forth. It targets only ASR and speech translation for the time being. And so in Metween, the sort of official model that we build is called Speech LMM. Okay, that's for large multimodal model. And you can find it on Hugging Face, obviously. And you'll find it can be fine-tuned, and we have fine-tuned it for you. So we've got checkpoints for a large range of tasks. And as time passes, we'll be adding tasks. So there'll be version 2 of Speech LMM as well. And we recently had a paper at Interspeech this year where we looked at a couple of interesting aspects of how to build this model. So the way, the architecture of Speech LMM, common with many similar models, is we've got an LLM backbone. So we utilize an LLM backbone here in the paper here. We are looking at either Mistral or so Mistral 7 billion or Llama 8 billion. And what we do is we encode, like we feed this LLM with either the text, tokenizers, encoders that we know, which is the native one for the LLM that produces text tokens as we know them. But then also we add the audio modality by producing an audio, a larger chunk, which is an audio modality adapter. And this produces tokens, which we expect to be in the same embedding space, the same representation space as the text tokens, but they come from the audio. So how do we do this? This is what we look at in the paper here. There are several ways to do this, and we benchmark several approaches to understand how it's best done. So what we do is we reuse a frozen audio encoder here. We go through length adaptation, and then we have what we call a modality adapter, and this produces these tokens. So what we look at in the paper is we do a sort of systematic study comparing the types of adapters that we can use with a choice of, we look at what happens if we only use Veneta transformers. We introduce convolution layers. What happens if we do the continuous integrate and fire paradigm? We use CTC loss, and here we use a window level Q former, and we try and work out some findings based on this. And what we see is the window level Q former is very strong. And importantly, the choice of the adapter and the encoder, they're interdependent with the choice of model that you do. So this, I would say, my own take on this is that we've got a couple of findings here, but it's probably not the end of the story, because so much depends on the LLM itself that we want to understand why it is, or what is it specifically that makes some of these adapters work well for some of the models. Okay, we've got similar work going on at Karlsruhe Institute of Technology, but from Jan and Maike, with clever ideas, same setup, clever ideas for how to do pre-training instead of doing directly task fine-tuning of the modality adapter that I showed on, in the previous paper. Here, they've developed an idea and published this paper showing that it's a good idea to do, contrastive pre-training. Contrastive how? Well, what they do here is they do layer-wise contrastive pre-training using the INFO-NCE, the informative noise contrast estimation loss. And they use ASR data in order to do that. Because there, you've got the two modalities, you've got speech and text, and you can ensure that in between the text and the audio parts of the model, you can constrain that the modality information gets forgotten and that you only get the verbal information that gets preserved. I'll skip a bit of that. Well, you can find all that on Metween papers online, obviously. If we open up horizons, and that's where I'm going to speed up, I guess, to move on to a conclusion at some point, we do much the same thing, but expanded in Dupes. And this is the reason why, I started with Dupes, and I coordinate both projects, really. So in Dupes, as I said, we've got these application domains. So what we do in Dupes is that we scale over modalities, which is not something that is done usually. So we're thinking of not just 2, 3 modalities like I was speaking about here in speech, but we're thinking about tens. And in fact, we're as ambitious as to speak of hundreds of modalities that we'd like to have, I would say, joint architectures for. So this is super ambitious, but it also sets the direction for us to start working on stuff like, looking at solution that can accommodate from an architectural and sort of training recipe point of view, very many modalities at once. So this is something very typical in Earth observation that we call geointelligence in the project, where obviously we have all images from patches on Earth. They're all 2D images. They can be aligned latitude, longitude. They have this interesting thing that we don't quite get in speech, which is they're at varying resolutions, all very heavily pre-processed. And we want to do some stuff like classification, segmentation, recognition, many tasks that have their equivalent in speech processing as well. When we look at cardiology, so you've got a lot of similar things going on and some differences. So we're still looking at natural objects, which are a patient's heart, but I would say the alignment is much more difficult than the 1D marker alignment or time alignment that we can do in speech, or the 2D latitude, longitude kind of alignment that we can do in satellite imagery. So here we've got something that moves the heart, that is elastic, that is imaged or that is projected under different planes, that has different shapes according to the patient, that develops over time. So this is an object that is much more difficult to map, obviously. We were lucky enough to have the developers of 4M21. This is the group of Amir Zamir at EPFL. And what they do is they work on natural images, and they work on 21 modalities to do with natural images. So this is stuff that's both mappable to 2D, but also then stuff that is text modalities, so descriptions or comments, captions, for instance, on images, and then metadata modalities, stuff like bounding boxes or identity of objects that you have there, and so forth. So the interesting thing about this is that it's not all 2D images that can be mapped to one another. And so we'd like to take the interesting architecture issues that surface when we look across these domains, as disparate, as heterogeneous as they are, and we reuse the good ideas that we find in the architectures of these models, and we make them work in one of the 3 or 5 domains, okay, in the future that we will have. So for instance, a very interesting aspect of that is, what happens between modalities. So the very interesting information theoretic angle between, mutual information between modalities, information content of modalities. So, sometimes you have modalities that complement each other, contradict each other, overlap each other, and so forth. So these are all things that are important to look at addressing the modality gap. So the issue, okay, that when you map here, for instance, you're trying to map same caption, different images into the same joint embedding space, which is supposed to be both for text and for images. But what happens is that, okay, you might manage sometimes to bring it to the same point here with text, but then you've got what's called this modality gap, where when you try and do it with images, oops, then you're no longer in the same point. This is the modality gap. And instead you're carrying over in your embeddings something that is specific to the modality and not to the content. And this interesting paper that came out at ICML 2025 this year, by Cambridge colleagues of mine, former Cambridge colleagues of mine, is a very interesting take, I find, and recommend the reading, to do with the idea of using the information bottleneck. And what we know, the idea here that when we use the info-NCE loss, we when doing typical contrastive learning, well, this is not the end of the story. That's what they contend in the paper. So they say essentially that when you use info-NCE, you have sufficiency. So you manage to bring together, to optimize 4 representations, which effectively are sufficient. But what you also want is to have minimality, this extra criterion, which makes sure that you don't carry modality specific ballast in your representations. So I think this information theoretic angle here, this is typically something that we're gonna look at in DOOPS. This is also important for when we look at speech in its multimodal manifestations. In DOOPS, we also look at multimodal reasoning, which is something that comes out in speech when we look at sort of like instructions and tasks, when we can start to reason about, I don't know, you have a long audio track, for instance, a meeting track, and then when you start doing natural language, sort of LLM style questions or reasoning about what's going on in the track, and you need to go back to information like timing, or like information like segments or diarization, what was said before, what was said later. And so you effectively need to reason on the audio and not just on the text, at the text level. Okay, so this is where it becomes really interesting in terms of what we call reasoning, because so far, you know, everything that's published and that's about chain of thought or reasoning, you know, verifiable rewards and stuff like that, this is to do every time implicitly. We're only ever speaking of verbal reasoning in text, okay? But what about reasoning in images? What about reasoning in sound? This is not something that we know how to do yet, and yet it's obviously full of promises. Coming to a conclusion, so you know, back in December 2023. This was at the time we were writing the proposal. This was one of the ideas that resounded with me when I wrote the proposal for Metween. You know, the people at Seamless M4T, in their conclusion, they were saying, you know, there's not been enough work yet in visual modality, using gestures, and so forth. So this aspect, this was back 2023, and I think it's still very much true today. Okay, and so the recap essentially of this talk again is that with speech we've got this very rich manifestation of language in both in production and perception. It's multimodal because it's a physical activity, and we have seen how it has parallels with other language manifestations. And the hope that we have working on Metween and working on DOOPS is that there are advances that come from other multimodal problems, and that we can play this game, or circulate, go back and forth between bringing up problems at the application level and ask for solutions at the research level, and then transport the solutions that come from research over to different applications as well. I'm really interested in hearing your work in this area. Also, we are hiring for our project, so come to Translated's careers website if you'd like to apply with us. Thank you so much for your attention today.
Thanks a lot, Sébastien, for the talk, and we do have time for some questions, if any. So please, if you have, just unmute your mic and ask.
Thank you.
Actually, I can start with one. You mentioned multimodal reasoning, and probably one problem in that domain, especially for reasoning from speech and audio, is the lack of data set. So I was wondering if you are aware of some specific data set that could be used for this kind of multimodal reasoning, especially from speech and audio. I know that for images there's a bit, but maybe less for...
Okay, so yeah, this is a really good question, because obviously data is the crux here. So I would say, so currently this is totally underdeveloped, and I don't know of any, I would say, specific data sets that target this. But the good news, I would think, is that, so for instance, in MCIF, we work on stuff like speech question answering. Okay. Or so it's questions like who's the first person to speak, or who's the second speaker, or at what minute and second does this keyword come up, or can you summarize what the third speaker says? Okay. So if we use these tasks, then I would guess that a point of departure, at least, would be like, for instance, we've got these in text forms, and we could do synthetic data, and we could verbalize all these questions, and have a model that is speech only. No longer needs to be no longer needs to represent text, for instance, can be speech only, audio only, okay, and can do audio only reasoning. Okay, so here what I'm saying, what I'm advocating is we can start with existing data that contains text instructions, cheat, do synthetic data, and here we go already, we've got a starting point for speech audio only reasoning. And I think we can do the same with a couple of other modalities as well. So that's to say sort of data augmentation, data synthesis based, and already that should get us started. And then I'm still waiting for people to, define some of these tasks. I'm only sketching them out here, but you can sit down and try and think of some of these tasks. And I think they're really interesting because they're the tasks that occur in applications and that we don't really have an approach for today.
Thanks. And any other questions? I really love the video of translated you presented at the beginning related to non-verbal features. So I'm wondering, is it available online somewhere? I would like
Yeah,
to
it's on YouTube. Yeah, you type human touch translated and you'll find it on YouTube.
Yeah, okay. Well, very good. And about non-verbal features, non-verbal aspects, so is it something that is addressed in the Between project, for instance?
Yes, absolutely. We work on all three, I would say, channels, audio, video, and text in the project. And so, like I was saying, cocktail party effects and using audiovisual speech information, and then also generating audiovisual aspects. This is all part of the project, absolutely.
Great.
Thanks, Sebastian. I don't know if my connection allows me to actually ask a question.
Yes, we can hear you.
I had to move to be like moving around the city. So it was very inspiring. I'm very happy that you have presented this. I'm looking forward to follow up on the number of papers that you have suggested. And I wanted to draw your attention to one more area that I'm aware of, and that's called the pixel models by Elizabeth Zaleski and others. And the idea they have is that they use translation to start from pixels. So the original starting domain is text translation, but they actually switch it, and the transform models are set up so that they process images at the start, images of letters. So that's one more thing.
I remember seeing this. That was probably 2 years ago at EMNLP. I remember a poster exactly about this. So I haven't been keeping track of the developments, but if I had had more time, I'd probably have read up again because I've lost track. But this is, thank you, Andre. This is very typically the kind of, I think, fertile research ideas that we want to develop more. Yeah.
And then I had a question for your dataset before you mentioned the work by Mike and then Jan US on the foundation models for speech and LLMs together. You didn't say whether your data was parallel in any sense. So was it parallel or not? Because Mike and Jan then used it. They used the AIR's datasets, which makes it parallel.
Contrastive. Yeah.
So in your case, in the first one. The speech foundation models and LLMs, was it parallel?
So in this paper here, the interspeech paper, so the evaluation we did on ASR and speech translation. Okay, so essentially we measured the goodness of I would say the combination, the LLM itself, the choice of encoder, the choice of adapter. We measured the goodness of that based on the tasks, ASR and speech translation.
And the original data sets were parallel in this regard, right? Like speech translation data sets and ASR. Okay, yeah. Thank you.
Yeah.
So again, thanks a lot for an inspiring talk.
Thank you so much.
Any last question? If not, well, thanks a lot, Sebastian, for the talk, and I think we can now wrap up. Some speakers have already left, some system presentation, and also our first keynote. So I guess that we can just all thank everyone, like the speakers, organizers, and I don't know, maybe André, you want to have the last word on this, if you're still.
Yes, if it's possible. Thanks a lot to everybody. That's just it. And we felt kind of depressed when we had just the two submissions into the task. But I think that still, AUTOMIN, even for this final like workshop and the wrap up and the keynotes, raised up to its value. So after this final day of the AUTOMIN share task, I'm really in a positive mood, and I'm looking forward for 2 more years to come, and then have the fourth AUTOMIN in 2027. So like keep up with us, and that would be my thing. Looking forward to seeing you later, maybe in 2 years or at the next AUTOMIN.
Thanks for the last words, and I guess that now we can wrap up. And again, thank you, Sebastian, for being with us.
Thank you, everyone. See you.
Thank you.
Thanks.
Bye-bye.
Yeah,
Bye, everyone.
Bye-bye. Bye-bye.